Hey, everybody. Welcome to my inaugural Future Rodeo podcast. I am super excited to have Anna Claiborne, the CTO and Chief Product Officer of PacketFabric, joining me today. For those who don't know, PacketFabric is a network provider driven by APIs. And I almost feel like, Anna, you're probably better to introduce it than I do. Although I will say, for everyone, that I had a certain kinship. I think you changed it slightly, but I feel like your LinkedIn title used to say automate all the things. And I pictured the meme. And I think it's now says automate everything all the time, which is like
Yep.
the slightly more business professional version of the same sentiment. But tell us a little bit about PacketFabric and what you guys do and how you got there.
Sure. So I think, especially as a customer, you do an excellent job of introducing us. So PacketFabric is a fully automated service provider. In fact, we were the first fully automated network service provider. We look back at the trends over the past 10 years, basically, before we founded the company, saying that the direction of everything was going towards infrastructure as a service. And that's the way compute had gone. You went from spinning up servers and taking care of them in racks and doing cabling and figuring out Pixie Boot for all your installs to all of a sudden using an API or a couple mouse clicks on AWS. And so the concept was, why can't that be done for network? And there was really no good reason once we dug into it. And a lot of us having been either network operators or in highly adjacent fields with like security that used a lot of network, it seemed really natural. We dug into it. There's no reason why it couldn't happen. So we did it.
That's cool.
And yeah.
I had this very brief stint at level 3 where I was really excited about APIs at that point. And I think this is still this is around 2016. And so people were still talking about metrics like time to first hello world. And I was excited about developer experience. And there wasn't necessarily what I'd say the will or the vision to do it. And so it wasn't much later. I think I was at Faction in maybe 2017. I get the first intro to PacketFabric, I want to say, in the early days. And I was immediately blown away because it was already a thing that I had wanted, right? It was this completely API driven thing. And the moment I'm asking that critical question, well, does the whole portal use the API? And I think whoever was driving like immediately popped up the developer console, like, yes, it is, and watch. So I always love that experience. So, I mean, you're there. I think there's probably a lot of ways to go about even asking around this, but maybe I know a little bit of the backstory here, but tell us a little bit about how you ended up in tech in the first place, because I think it's really cool.
Oh yeah, it was. I mean, it was an interesting journey to be sure. So I started off in college. My degree is actually in genetics, and so I actually switched because I started off in chemical engineering, and then I realized that I actually enjoyed living things a little bit better than chemicals anyway. And so that was that switch. But in high school, I started working at a bank. I, like most people in our very particular generational slot, I was into computers super early. I had an Apple IIe that I played Load Runner on. And I tried designing levels. And I also had a variety of like 386 machines, the classic 9600 baud modem. I was on the BBS boards early, all of that. But it just sort of seemed like play. That it always seemed like it was a playground. It wasn't anything that I ever, that a younger self would ever realize would go anywhere. I was like, oh, this is a cool thing.
The
And it's
best
fun.
origin stories in technology involve video games at some point, right?
Yeah, they really do. Yeah, so we actually like this. This is a little bit fast forward, but I was working at a bank, as all 14-year-olds do, taking care of the network and working on the Fedwire machines and things like that. And so the guys that I worked with at the time were this great bunch, and I got them into Doom. And so I was like, yeah, we can use the LAN and we can all play Doom. So we crashed the corporate LAN playing Doom.
Nice. Yeah, I think you know about Exodus, and it was kind of one of my first big gigs, but there were a lot of late nights where people were playing Warcraft. I think it was Warcraft 1, possibly 2, Tides of Darkness. I just remember I didn't play the RTS games very much, but when everybody got into Diablo, I was playing that on the LAN. So yeah, definitely we lived that, of course. And when you're young and you pretty much all your friends are your coworkers anyways, which was the case for me anyways. It seemed totally appropriate.
Yeah, it's being at a bank, all my coworkers were 40-year-old men who'd all worked at IBM and were programmers and who were actually amazing. They were amazing they were amazing mentors. They really were.
They weren't great Doom players though, right?
They were not. No, and I think I was in the Quake. I think Quake was out shortly after that. And I got super into Quake and Descent, and I remember they would tell they would be like, "How can you look at that? It makes me nauseous." When I was playing Descent, and being like, because it's yeah. And so yes, they were not great video gamers. They appreciated it, but they had a ton of wisdom. One of them had actually worked on the original C operating system back in the day, constructing the C language. So at any rate, I was working at the bank and doing a lot of things like basic Windows 3.11 installs, troubleshooting, that kind of stuff. And then I started working on the network and taking care of like the Novell 4.11 servers and working on some of the Cisco switches, very basic command line stuff, going in and troubleshooting. And so then it eventually evolved into, well, why don't you take care of the telecom stuff too? So frame relay, ISDN lines. I got kind of involved in everything. So I was there every day after school working. And I had this sort of separate interest in science. That's what I enjoyed. So that's what I went into in college, in chemical engineering. And there was a ton of computer science courses. So I was like, well, yeah, of course I want to get better. I think at the time I knew like basic and VB access. That is what I had known. And I was like, oh, there's a C course. Like I know a guy that worked on that. I got to take C. So I took C and I ended up doing a minor in computer science, just working through those courses. So, and what I had functionally ended up doing before this even existed, the actual first ever bioinformatics class was my senior year of college, is that I kind of gave myself a bioinformatics degree before one existed. And just the combination of taking all the CS programming classes as far as I could and doing the genetics degree. So that's when I got out and I had these big dreams that I was going to go work for Genentech and I was going to work on the shotgun DNA sequencing because that was the cool new thing in genetics at the time. And I applied and I talked to the recruiter and they're like, I was thinking that I was going to get one of these super cool research positions to go do this. So I was like, I have all these skills. I can do this. I know how to program. And sure, I was asking for a PhD, but I was like, can't be that important. And I talked to the recruiter and she shot me down really quick. She's like, well, if you want to move to Maryland, you can get a job as a lab assistant with a bachelor's degree. And I was like, that's not what I want to do at all. So I ended up going to work for Tower Records, who had a sign up in the quad at Davis that said, we're looking for software developers. And I was like, that sounds like I can go do that right now. So I went and worked, it was me and handful of other people that did towerrecords.com back in the day, which was their highest performing store because it was a store. They counted it as just another store. So it was the highest performing store in the company and also the lowest overhead.
Yeah, no doubt. This is the dawn of the internet era.
Yep.
It makes me wonder too. I mean, what do you think would have happened? I mean, if you put today's brain in just graduated body back then, but you still wanted the job, how do you think things would have gone differently at Genentech? Because I often wonder about like how life experience and the perspective we pick up affects those kind of interactions. Like recruiter shoots you down, you pretty much went, okay, well, I'm not moving to Maryland to be a lab tech, but how do you think it would have gone today?
I would have today, if my today brain was in there, I would have called Craig Venter. I would have found his phone number. He was like the founder. I would have called him and I would say, I want to come work for your company and this is what I want to do and you're going to hire me.
Yeah, probably would have worked out too.
Yeah. Yeah. But
I don't know if you've done this too, but I mean, I think I've had a few people that I've hired who they weren't necessarily the right person for the job, but they were like already knocking down a door to even have the conversation, right? And you just think to yourself, like, okay, normally, like, I'm desperate to find this level of like enthusiasm.
Yeah. Oh,
yeah.
It's such a rare thing when you find that level. It's like, of course, now that we're very sage, we're wise, we're sage, we have all this experience.
We can pretend anyways, right?
That's what I'm trying to just say, I'm trying to find all the nice words for being old. We're wise to the ways
Uh,
of the world. It's a completely different approach, and finding that useful enthusiasm, and just the sheer not even caring about what you don't know is so precious. And now you just like want to snag it and bottle it and use it for good. And so I'm sure that having that perspective now, yeah, I would have just gone in there like bull in a china shop and done it completely differently.
yeah, have you seen that chart where like at the top it begins in the timeline at 0 and it's like the person thinks they know everything, but as they're learning, they realize they know less and less and less until they actually end up in this like depressed trough, this funk,
Yes.
but they keep going and then they start to get actually towards useful ignorance and like a little bit of growth of knowledge. I always feel
Uh-huh.
like the more you know, the more you realize you don't know. And at some point you throw your hands up and just go, okay, I'm never going to know even a fraction of all these things there are to know, but I'll just devour everything that I can and try to keep it useful as I go along.
Yeah, that's exactly how I feel, is that you just
Mm.
there's so much out there that you can never know about, and it's pretty much an endless treasure trove of insight. And I mean, it's the internet. The internet makes the body of knowledge available to humanity just increase exponentially all the time. You can
Mhm.
never keep up with it. So I almost think as we go on, that the trough of the imposter syndrome, like I'm never going to know anything. I almost think that gets exponentially worse because you realize that there's just so much you will never know. So all you can really do is investigate the things that you enjoy and try to contribute at least a little meaningfully.
Yeah, I mean, I always like to say we live in interesting times, and I remember going to a Usenex
Isn't that a
conference and
Chinese curse?
huh?
Isn't that the Chinese curse? May you live in interesting times.
Oh, is it? I don't
I
know,
think it
but
is.
uh, it cursed me all the time. Then, yeah, we definitely are living in interesting times. I mean, it's good, interesting, I guess. I can skip like war, famine, and disaster basically, but as far as technical upheaval, I'll take that all week, even if it means total disruption. Um, And I remember Marcus Random having this slide at the end of a Usenix conference where he said, if you can spell TCP/IP, it's a good time to be alive. And I was like, okay, I guess I agree with that, right? Because already I think I'm like 22, 23 or something. And the opportunity just was like exploding in front of my eyes. The great part is like, at some point you have this belief, like, this is going to change everything. And then now we get to look back later and go, oh, it did.
It
Like, it just,
did.
we were actually selling it short, arguably. So
Yeah.
let me ask you this though. Here we are. What do you think about actually it's a kind of a question, two parts. Let me ask the easy part first. Somebody comes to you. It's like your neighbor uh that you're friendly with has like an 18-year-old that's just graduating high school and they're interested in everything, right? They're like, oh, chemistry, biology, physics, computer science, but I also love English literature and I thought maybe I could be a lawyer. Anyways, and you're thinking, and they're like, what do you think would be what's the coolest thing I could do? What do you think's the best path forward or something? They're just looking for the world's most generic advice, but they're interested in everything. So it's kind of unbound. And I kind of try to tease out this idea of if you're starting the beginning of a career, beginning of an education, a secondary education career today, what do you think the coolest thing you could be doing today is? What would you tell someone to study or learn about, or at least think about?
So this is your easy question. I'm now terrified of the hard question. So
This is there's no right or wrong answer though. So that's
well,
the easy
this
part.
is a heavy, I mean, this is a heavy question. This is the existential, like, what do you want to be when you grow up question.
And you're giving it to somebody else, which makes it so much worse than answering it for yourself, right?
Yes. Yes, it
That's why
absolutely
it's
does.
imaginary person, although
Okay.
someone
And
might actually listen to this someday and
yeah, yeah, and take my advice. That is
take this with a
terrifying.
grain of salt, all ye who listen, but
So I would get into it, and I'm taking this through the lens of like if I could do it over again, because I think that's really the only lens that you can take it through.
yeah.
You have to take, because it is important. You have to listen to your own interests. And if your own interests are all over the place, which I think both of ours are, like we definitely are interested in a huge array of science and technology. So I would go into something very specifically cross discipline, like the intersection. I love xenobots, making sort of little programmable cells that can do things like that idea, the interface of computers and biology. Material science is like super fascinating. I've had several times in my life when I'm like, I should go back to school for material science, because when a new material comes out, it is one of those fundamental changes. It's the first building block or the foundational building block for this whole other entire ecosystem on top of it. When you come out with a new battery, or a new even thing like Vanta Black, the carbon nanotubules that make Vanta Black such a absolutely non-reflective surface. And so when you come up with just a very basic thing like that, what is built on top of that is just you really are revolutionizing everything when you come up with a basic unit like that. And then the super cross functional domains, like computers and biology, are fascinating, because that's where a lot of the real advancements will come from. And it's not to say that you couldn't do something super profound if you were a physicist, like you wouldn't come up with a unified field theory or something like that. I mean, I hope that there are lots of people who want to be physicists and do something like that. But when you kind of when you're an expert, or as close as you can be to an expert in two different domains, and you're working on those simultaneously like that cross function is super neat, because you get these emergent things out of it that it's not in the observable universe that we're in right now. You get a whole new thing.
Yeah,
So
you've probably had a lot of people that you've worked with, or maybe even hired, right, where they started off in a hard science and then ended up in computers. And then to me, that's always been a little bit of a pattern, right? It's a good
Mhm.
sign. I actually remember literally maybe 20 years ago, somebody kind of denigrating literally a physicist who was trying to apply to the knock at Exodus. And I just remember kind of like quietly in my cube face palming, because I was thinking, like, it is so crazy if you'd be making fun of that person. It is so lucky for us that they're so interested in this field that they want
Yeah.
to come over, because they're probably going to bring some knowledge of technical skills along with just like this diversity of knowledge.
Yeah, and it's interesting that you say that, because I kind of wonder what's going to happen to the future of computer science now. Because computer science for computer science sake is, I don't want to say that it's like played out or anything like that, because it's not. I mean, there's still plenty of advances to be done in the field of computer science, but it seems that, at least to me, all the interesting ways in which the technology is impacting other things is the more interesting thing. And so again, that's why I go back to the sort of cross-functional domain, is that computers, sort of the ultimate thing that we're seeing out of that right now is artificial intelligence. It's like, how can artificial intelligence, the ultimate, the pinnacle that we've reached so far for computers and when what they can achieve, how is that going to alter the trajectory of neuroscience? How is that going to alter the trajectory of mining? Like, like maybe AI will be able to better predict deposits of precious metals and lead us to the new sources of rare earth materials that we haven't found before. So it's more like, how can computers now augment everything else in our lives?
Yeah, but I really do wonder too if there's like an analog, and maybe if there's an analog in some of the fields, because I think about computer science and I think about folks who, back in the day, as they were working towards a dissertation, it might have been in something like graph theory or provable algorithms, right? There was this really strong link, I think, especially in earlier computer science, between things like lambda calculus and then the actual programming that you did behind the keyboard. I have a friend who wrote his dissertation on basically the security of social networks, right? And
Hmm.
it's so derivative, right? Because it's a computer science degree, and yet it is certainly related, but it seems more peripheral. And I wonder if we'll see this evolution where, similarly to have like your own journey at school, right, where you start off in this a hard science, but it wasn't like theoretical physics. It was like something that was going to be practical. And I
Yeah.
wonder if we'll see more acknowledgement, like that there is still a thread of computer science that is completely theoretical, that like heralds back to Donald Knuth and Mix as a programming language and really deals with like that low level construct. Maybe it's tied to hardware, but then there'll be people who are, I mean, this is already happening, I guess, with things like ML, but I guess, wouldn't you say that you see this sort of thing where research then starts to happen at many different layers, like computer science maybe is just not a descriptive enough term?
Yeah, I feel like there's so many sub-disciplines now within computers. It's such a broad thing. Like, it's not a very descriptive term anymore, because
Yeah.
it's like saying science now. It's like,
Right.
okay, great. What
Like, oh,
what
if you
branch?
forget science.
Yeah, Yeah, I like
That's
science.
that's a
It's
great way
not.
somebody goes, "Sure you did."
I science.
Science.
I science a lot. I do.
Like in Good Will Hunting, where he's like, "Oh, I took history," and he's like, "Oh, history, huh? So it was a survey course then." You're just like, "Oh, this is embarrassing. I feel bad for Ben Affleck's character. He's walking into one."
Apples,
So
I like them apples.
yeah, exactly. That's a great movie. I'm glad you brought up the AI thing, though. It takes me.
I
It's
know.
hard to hold back, right?
Oh,
But really,
it's
I
the
do want to
hot it's
ask
the
you about the
hot thing right now.
biology. No, it's super hot. Literally somebody on my own team sent me this graph of like the fastest known things in the universe, and it's like cheetahs, etc. The speed of light, and then the one that was faster than the speed of light was people becoming experts in AI. And I was like, I resemble that remark. Like, so,
Yeah, I'm not an
uh,
expert in AI. I'm not an expert in AI. I mean, I have thoughts on it. I find it super interesting, but I'm an expert in AI, and I'm an expert of asking ChatGPT questions. I'm really good at that.
yeah, no, I'm in the same boat. Although it has me like studying linear algebra. I want to say again because I did some and had some applied discrete math in school and things of that nature, but not. And actually, the thing I was surprised about, at least so far, is especially when you're writing everything as code in Python anyways, the math's a lot easier than I thought it was going to be. And I also was really surprised at how easy it was to see the link between very simple like linear regression and polynomial regression, like stepping into LLMs when you start realizing that they're just vectorizing all of these tokens in the prompt and then vectorizing all of these like n-dimensional spaces to kind of form the neural net and traverse it. So really interesting to see how like the idea of computing a loss function could apply basically from the most basic thing into like the really complex things. But yeah, I'm definitely like a really enthusiastic novice, and I'm almost embarrassed because I keep putting out these little mini podcasts in enthusiasm. Although I'm mindful of people like Richard Feynman, who basically said, if you want to know if you really understand something, go to try to teach it, right? Because
Yeah.
and I find myself going, I want to say this thing, but is that true? Quite a lot. But what I want to ask you really is about the applicability to biology. And I'm trying to remember the last time we had a conversation, because we certainly got into the biology of it, but
Ah,
I know you hadn't read the State of AI report, and we agreed we'd talk about that. But
yep.
I'm wondering if you caught if last time we had talked, if you had seen the thing about open fold and deep fold and the whole proteome being sort of predicted, basically, which I think it's up to about 80% accuracy now.
Ooh, no, I had not seen that. I feel like I need to
Yeah,
Google
so
that right now.
I know, right? Figure this would be right up your alley. So I mean, the gist of it, of course, is deep fold and then open fold, which was an open source in the vein of deep fold, was basically looking at the three protein structures of amino acid chains. And then the idea is you can take any amino acid chain, it would try to predict the shape it would have. And there
Huh.
was some software that did
Okay,
this
so it
apparently
did predict.
before,
So it
but it
did
was so,
predictive protein folding. It basically got trained on all the known proteins, and then it said, "All right, given this chain, okay, that's good. I think I can kind of figure out what it was doing now, even without. I
yeah.
just Googled it, but oh,
Mind
that's super
blowing part
cool.
of this is I remember literally putting nodes into the folding at home project like 20 years ago.
I
But
know. I
the
did
mind
too. I
blowing
too.
apparently they have now run the process to predict every feasible amino acid chain, and something like 80% of them match the predicted protein. So like the amount of effort going into like cryo EM work to do things like use electron microscopes to actually build the proteins and then see the structure they have is like shrinking massively because end up getting it right the first time, like 80% of the time. And so the work has shrunk. And I don't know if it reduces the remaining 20%, but it does make me wonder, like, what does that mean for biology and research when you get so much horsepower out of an ML model?
That's a really good question. I mean, it could potentially allow us to build like novel proteins for completely new use, because if you can put together a string of proteins, predict how it will fold, then you can predict how it's going to interact with other things as well. So it could allow, like, scary because it immediately makes me think that we're going to accidentally make prions that are going to kill
Mhm.
that are going to destroy all life as we know it. So
Can we just designed
I'm
the
like, oh
zombie
man,
apocalypse?
yeah, maybe
Yeah,
that's a bad
actually, it's funny you
idea.
should say that. It's always viruses in the movies, right? But it really, actually,
Oh,
it being a prion disease makes arguably as much or more sense, right?
in the
Yep.
scale of what scary. You have bacteria somewhere way down here, and then viruses, or maybe there's something below bacteria, but then way, way, way far out there, you have prions, because there's nothing that kills those things except for fire. That's it. I mean, they can freeze
Wow.
in space, be fine. Doesn't matter. Sit around on any. I mean, like, you need something in a living being. You cannot destroy them, because they are the essential building block of life. They are a protein. Anything that is going to degrade them is going to degrade everything else in your body. It would have to be something that was highly targeted to that exact protein, and that exact protein, the only thing that it does is reconfigure other proteins just like itself. So
Mm.
tell me how you're going to get a protein to attack a protein that's core function is to change other proteins.
I do wonder if you can have, I mean, seems like the sort of fighting fire that ends up burning the world down, but I wonder if you can build a sort of like a mirror protein, right? Something that kind of caps it off, basically, where it wants to bond to it, and then gets stuck,
Yeah.
basically,
Yeah.
because it tries to go and reconfigure the other protein, and it ends up
And it goes,
just wedging it together, and they both, like, literally an acid and a base reacting, right? And,
yep.
you end
Yeah.
up
And
like neutralizing each
neutralizing.
other.
Yeah.
Yeah,
Neutralizing function.
I don't
Yeah.
know.
That'd be really interesting. I mean, to date, though, I don't think anyone has come even close to creating anything like that. It is terrifying when you think of us creating new proteins and accidentally stumbling onto the
The
omega
ultra
prion.
prion.
Yeah.
Oh, yeah.
The,
You had to say omega, didn't you? Right? To
I
make it sound
did.
extra like end of the world. Yeah.
Well,
Well,
I was already thinking, what would be the scariest name for that prion? The omega prion.
that was good. That was off the cuff. That was like, literally, if we write that on a napkin, someone might option that for the movie right now. The omega prion. Oh, that
Maybe I
doesn't
should.
sound, that's people are like, what's a prion? That's,
Yeah.
so,
Yeah, I know. Yeah,
um,
because everybody knows Mad Cow and
yeah,
Creutzfeld's
yeah.
Jacobs and all. Yeah, they know the emergent
They know
diseases
mad
from
cow
it.
anyways.
Yeah,
Yeah.
yeah, at least Mad
Um,
Cow.
It's interesting though too, and I guess I've had the privilege to interact with a few companies doing pharmaceutical research, so I've actually gotten
Oh, that's
to
cool.
talk to some people and see some teams discuss what they've been doing around the
Microscopy.
microscopy. Yeah, don't even. It's
Microscopy.
like that
Uh,
word, that thing you do with electron microscopes. So talking about that,
mhm.
and it's so interesting to me because it's so heavyweight. I actually had friends that worked on rented time at a university on an electron microscope because they were trying to crack smart cards back in the day. And I remember they
Oh,
spent like over $100,000 of their own money on this R&D because they were looking really deeply at how the cryptography was implemented. And they did crack them all. That didn't open the door for their product the way that they wanted. But it makes me wonder, basically the gist of it was that a lot of the future here would look like people going, okay, we need something that does X, knowing exactly what that protein structure would be, just to the way you were talking about, and then just going, okay, let's search the database. What amino
mhm.
acids do we have to put together to get this protein? And just like being, and then like that level of, I mean, you used to hear the term designer drug, and I don't think that was ever coming close to this actual version of designer drugs,
Yeah.
where you're going to have things that are potentially tuned to your DNA. I mean, that actually was the other thing. Have you heard about this pattern of pharmaceuticals where it's, say, 30 or 40% effective in a population, and it turns out it's not because it's a kind of poorly designed compound. It's the DNA differences in the cohorts. And so it's like, oh,
Yep.
if with these set of genes, it's 100% effective or 95, and then for everybody else, it's close to zero. And so you want to think about prescribing this DNA test. And if they've got these genes, then go ahead and prescribe it because it's almost certainly going to work. That's like mind blowing to think about how that could revolutionize like how quickly we do drugs, and how effective they are and how well they're prescribed, all those things.
That it's like it's funny to me that we're finally coming to this realization that genetics affects for example, how effective a drug is in your system, because it's been common knowledge for quite a while that if you look at a child, you say, oh, well, what's that child going to be like when they get older? Oh, well, it's 50% genetics, 50% environment, right? And
Mm.
so if this is sort of that base level of knowledge that's been around for a while, that genetics has at least a 50% impact, it really is amazing to me that it's taken us so long to get to the idea that your genetics and the basic which is just the encoding for the basic functions in your body, could affect how you react to having a certain type of cancer, how you react to a certain type of chemo, how you react to a certain type of drug. It's kind of obvious when you think about it, and I think that's, I mean, don't get me wrong, I think that that's completely awesome that it's finally happening. But if just in general, I go stepping back to the easy question that you asked me a while ago about what to do, what would I advise somebody who's 18 to go do, is that there's so much potential in the medical space right now, just in general. Medicine, everything about medicine is just ancient. Like, I don't know if you ever look into how anything is done in medicine, but even so, when I was pregnant with my first kid, I got really interested in, like, 'cause they have all this advice for you, like, oh, well, you need to get antibiotics in the children's eyes as soon as they're born, and they need these shots. And so you start, and me being sciencey and curious, I'm like, why is this? What is the medical basis for this? So you look some of this stuff and it's absolutely mind-blowingly insane. So the reason for antibiotics, for putting antibiotics on children's eyes, is because in like the early 1900s, there was a handful of prostitutes that had children that also had chlamydia. And when chlamydia gets in your eyes, it causes blindness. So because of this, it is now 100% standard practice to put antibiotics, which, by the way, now there are far more children that are going to be allergic to that antibiotic than are going to be born to a mother with chlamydia because of advancements in prenatal care and STD screening. And so it's actually a greater risk to do that than it's like a greater risk to put an antibiotic on somebody that you have no idea how they're going to react to than to assume that this woman is going to have chlamydia when they have their child. So and so much of medicine is like this. It is built on, it has been started, the first medical school is super old. It's like, I don't know, Roman times, something like that. And so you have this body of knowledge that's been built on for so long, and it's almost ritualistic in the way it goes about its practices. It's not how, like, having an engineering brain and going into medicine is got to be maddening, because
How
they
many
have,
how many humors were there in the original, like, model from that? Is like black humor and bile, and I forget what all the names of them were,
yes,
but there was like
yes,
this whole taxonomy of things that just didn't exist at all, right? It was just like we're all proxies for some poorly conceived notion of whatever was real, and no
yeah,
one
it all
really
goes
knew
back
because
to, well, there was a bunch of people that had the Black Plague. We bled like half of them. Most of those people didn't die. So bleeding people is absolutely the answer when they get Yersinia pestis, which is the pathogen for Black Plague. And so it's based on just this very sort of like, it's just based on a lot of what we're now seeing rapidly as outdated knowledge. And there's a reason for that, because you don't want to go, if you're not using something that you know is going to only, it's only going to kill this many people and mostly it's going to be okay. You can't go experimenting on people with new
first do
ideas.
no harm.
Yeah, first do no harm, right? So if you know that something does no harm, you stick with that before doing anything else. There is a certain logic to it. But the amount of unexplored potential there is just off the charts in terms of what we can do better in medicine. And that comes to every single aspect of medicine, to how we apply, like, to actually, like, finding the underlying cause for conditions. Like, this is one of the things that just drives me absolutely nuts. Being an engineer, you like doing root cause analysis, right? Why did this happen? Why did this happen, so we can make sure that it doesn't happen again? All medicine does is treat symptoms. Why do you have a headache? Doesn't matter. Take an aspirin.
Yeah.
Okay.
This is
Like,
actually another thing, by the way, that got me surprised and interested, that I didn't really realize people were doing with ML, but maybe this is the least sexy version, right? Is not fitting to formulas necessarily, like fitting a line and trying to make predictions, but just something that can do sort of automatic cohort analysis, where you
yeah,
can actually feed a bunch of data in, and without any sort of like a priori theory about what's going on, you can just get it to, you tell me what the links in these populations and all these attributes are. And right, as more features you plug in, the more likely it is. I feel like people are and I mean, I'm including myself in this to a big extent, right? This isn't a judgmental comment, but it's like people are so geared towards storytelling instead of statistics. My wife always likes to point out to me, because she studies neuroscience, that when you tell a story basically that's personalized, and this is why you see politicians doing it all the time, that people are much more likely to remember something and believe it, in fact, when it comes with that anecdote. So the reason why Mrs. Smith in Wichita, when she shook my hand and she told me about her son Johnny who had this thing, like the reason that there's so much of that storytelling is because it helps get it into the part of our brain where it's remembered and believed.
Hmm.
But then you think about what we do statistically, and like the fact that we're so terrible as a human race about distinguishing between cause and correlation. It's one of the things I have a hope for with AI and ML, right? Is being able to automate the sort of part of the process where you're like, just let me feed you data and you dispassionately tell me what you see statistically without any sort of theory. And I feel like before, even science was tainted to some extent because we had to have a hypothesis to test, right?
Yeah.
Like you had to tease something out of the data that didn't make sense and come up with a hypothesis about it and then go test that. But what happens when you don't need a hypothesis? All you need is the data, and you have a system that will go and will test all the hypotheses for you basically and move toward it.
Well, isn't that the greatest saying? The best thing about numbers is they can tell any story you want.
Right.
Yeah.
Yeah. Lies, damn lies, and statistics, right?
Yeah. Lies and statistics. So now I'm gonna tell you a story about
I'll
that will make
remember it and believe it, I'm sure then.
I know about the potential, because we were talking about what it is that inventing novel proteins could possibly do. So I recently had a really good friend whose child was diagnosed with this super obscure syndrome, Kleefstra syndrome, and it's a heterozygous deletion on the chromosome 9q34.3, I think. Yeah, yeah. And so it surfaces, and it looks a lot like trisomy 21 Down syndrome in terms of effects, and the effects can be pretty ranging too. You can end up with a relatively functional individual who can hold down a job as still some amount of mental impairment, to all the way to somebody who's pretty severely handicapped and disabled. And this the segment of the chromosome 9 that this encodes, that is encoded for, is a histone protein. So a histone is something that other proteins wrap around. And I've been reading on this a lot lately because obviously this is a good friend, and yeah, I find this very upsetting too. And since it's rare, it doesn't have a lot of studies on it, but they did a knockout study in mice, which is where you knock out the gene for this. And just anecdotally, in the human version of this, deletions tend to be worse. Nonsense mutations seem to be less bad in the spectrum of actual presentation. So the knockout studies in mice, they were able to basically give them supplements of this protein, which is highly active in the brain. I don't know how they gave it to them. I don't know. It
Ah,
didn't say if they injected it directly into their brains or what. But they were able to give them supplements of this particular histone PLG, I think it is. And they showed dramatic and almost instant improvement. And it's like, that's pretty incredible. Imagine if we had the ability to do that on a bigger scale, just even the experimentation in mice to figure out what it is. There's a lot of problems, both genetic and otherwise, out there that could make a lot of progress. Or even if we could model it, if we could have AI model the potential of what happens in a complex system when we're changing things, because that's part of the problem. That's the problem with ethics and animal experimentation. It's the problem with experimenting with anything live, is that you unfortunately have to harm the system in order to test things. And if we could figure out a way to not do that, that's a huge leap forward.
yeah. I mean, one of the things that I end up wondering about is this practical now too? I mean, the knockout study, do they actually carry that out with like a CRISPR or some other technique in this case, they just applied it manually. I mean, is that the idea though? Like that, I guess in a case where there's just a lack of a protein because the production is somehow genetically broken, then you can create the protein and just administer it somehow, right? Whether it's
Yeah.
respiratory or injected or consumed. But then I guess we're also entering this era where in theory we can go and edit. I mean, you probably know more about this. I mean, is the CRISPR technique applicable to doing a therapy on someone where you need to fix the genome and it's something, what if it's something it doesn't reproduce a lot of, right? I mean, I'm not even sure what would fit, right? I mean, thinking about things where, I mean, yes, your liver, say, grows back eventually, but it's not like you're constantly regrowing parts of your liver. If you wanted to, say, use CRISPR to edit a gene in your liver because you were producing a chemical that was going to give you cirrhosis over time, is that something you can do? And eventually you'll have aligned with the targeted DNA liver, or is it limited to things that are being replenished, sort of continuous growth, or how does that end up working?
So, well, one of the fundamental limitations of CRISPR, or not limitations, but just unintended consequences of CRISPR, is that you have to specify a target site for cutting or whatever alteration you want to make, which is a sequence of DNA. And
Yeah, I was going to say, just by target site, you mean in the genome?
yes, a target site,
Okay.
sorry, a
Yeah.
target site in the genome, which is a series of ATCG in
Uh-huh.
some order. And so you have to provide that site that CRISPR is going to cut at and make alterations at. And just knowing, and that's one of the big problems, is because you get that target site, so that particular combination of base pairs. So let's just say it's ATCG. That may appear at the site where you actually want action. So it's like, okay, the liver is producing a harmful protein. We want to cut out this gene, uh, and so the body stops producing this protein. Well, that ATCG sequence might not just be there at that harmful protein. It might be in a lot of other places. And so you would get these unintended consequences of having other genes either rendered active, inactive, whatever the case is, throughout the genome. And that's one of the big still sort of hurdles that CRISPR has to clear for action within
Mm.
for being really effective in humans,
How
is that
long
you
can the
have to.
target site be?
That's a good question. I don't know what
It's
the
such a weird
limitation is.
thing. I've done enough. I get a little bit of. I played amateur life scientist on a project where we were doing this multi-cloud supercomputer, and I was running this thing they call the germline pipeline, right? Where you take the raw data that's been read from like an Illumina DNA sequencing device,
Mhm.
and it's called a FASTQ file, right?
Yep.
And the way it was described to me in abstract, basically, is like it gets a ton of reads out of your DNA sample, but it's not like your entire sequence reads in order, right? It's more like the way I described it to people, and I haven't had anybody contradict it yet, is like imagine a book, but instead of getting to read the book in order, you have like
You get it chopped
100,000
up.
3 sentence snippets
Yeah.
and tons of overlapping, and they're all like middle of the sentence cuts off, just a million weird things like that. And then, of course, the reason you end up using a supercomputer is because they're like, now put it back together in order. And you're like, are you kidding? And of course, that's what it does. It takes all these segments and aligns them. And there's even this company, Parabricks, that NVIDIA bought that then took the
Hmm.
Broad Institute's GATK toolkit and then ported it to GPU CUDA so it could do it like 30, 50 times faster than a CPU could. So now you can do that whole process, that whole sequencing of the FASTQ into a BAM file, right? BAM
Yeah.
being the binary line mapped file where it's like in order, or you can print it in order. But you can do that basically in sort of record time in like 40 minutes, basically, which I mean, actually, one of the things, have you ever seen the chart of like the cost of genomic sequencing over time and how
Yep.
it's plummeted? Because it's
Yeah.
ridiculous.
Yeah, I've used it's like
Like,
it almost goes like inverse to Moore's law. They kind of go like that. There's these really cool, they're called Nanopore sequencers. They basically plug into an iPhone now, and you can load like a little DNA sample into them. I can't remember the read coverage. It's not real great. It's like 3x read coverage or something like that.
wow.
But yeah, there are these tiny little things that plug into a phone. I was like, that's amazing. It's amazing.
I know we're like on our way to living in Gattaca, basically, anytime now. It's just the whole idea of like kissing your date and she runs off or he runs off to get a swab done, basically. Tell me if
Well,
this is a keeper.
here's the thing that makes no sense about Gattaca. If they like I don't remember the movie that well, but if they had all that advanced technology, so someone comes out with bad eyesight, you just fix it. Like, I mean,
Oh,
it doesn't make a lot of sense to me.
it doesn't in the context of now, but there was no CRISPR when Gattaca came out,
Mm.
and there was no fixing, and of course, it's not even practical today. But I think we have line of sight, right, where we almost like take it for granted that in 10 or 20 years we'll just edit DNA if we need to. But at the time, the chance they got was get 6 embryos going, and then you pick the one that is like closest to what you want, right? But then at the beginning of the movie, basically, the parents are sort of naturalists, right? So for their first kid, they're like, no, we're gonna do it the old fashioned way. We're not gonna get a bunch of embryos. We're just gonna snuggle, and next thing we'll have a baby, and we get what we get, right?
Yeah.
And it's not like he's bad per se, but if he's got a little bit of asthma, he's suddenly it's not like there's a whole bunch of other people that have that. He's now like one in a million because everybody else is editing out all of the bad stuff, right? But I love the tagline, right? There's no gene for the human spirit, which
Uh,
I don't believe, right?
oh
I'm
yeah, I
sure
know.
there's a question of like what is the gene, and how what circumstances cause it to express and things of this question. But yeah, still, it's definitely different in the sense that maybe we make changes. I'm always fond of telling everyone I want that short sleep, or the set of, because there's more than one, but I want all the short sleeper genes. Please CRISPR that into me as soon as
Yeah,
possible.
can I yeah, can I only I'd only like to get less than 6 hours of sleep every night.
Yeah,
I have the long sleeper genes.
me too. Me
Yeah,
too.
I need like 8 to 10 hours of sleep. It's ridiculous.
I have a friend who's got I guess he's got probably all the short sleeping genes, and he literally sleeps like 2 to 5 every day, perfectly
Oh,
happy all the time. And I'm so jealous. And
that
he was working in product marketing and product management, and he'd go to work and go, I'm not technical. And then he'd be at home writing code, writing like high performance AMQP buses in the middle of the night, basically. And you're just like, how would he, is this so unfair? Like, I just love
I
the
know,
idea of all that extra time.
imagine if we didn't have to sleep at all. Imagine like the things you could get done. That to
Yeah.
me is
Well, I
super
mean,
fascinating. I mean, aside from the fact that you will definitely right now, unfortunately, go insane and
yeah.
die.
Yeah.
That is a current downside to
It's a
that
bit of a
strategy.
downside. Yeah. Yeah,
But
or maybe it's better though to just go ahead and sleep and then just not have to die when if your time is not as limited, then maybe the sleep. I almost think I offended by my own mortality, and maybe that's why I don't want to sleep, because it's like, hey,
yeah,
there's only a limited time. Although to your point, I guess if you're not sleeping now, you're probably doing more harm than good, even on that score. So
yeah, but if you didn't have to, that's the point. That is exactly it. It's limited time. And if you're sleeping, well, it feels like it's making good use of the time for us high sleep needs people. There are much more interesting things we could be doing if we didn't have to do that.
yeah, for sure. I'm kind of changing topics. I think this has been bubbling up in my mind for a while now. I've been thinking a lot about LLMs and things like GPT and their ability to help you, especially if you have domain knowledge, kind of get from concept to code and execution a lot faster. What do you think about the future of APIs and automation? Do you see any clear impact coming from all of this ML, the GPT moment, and these things? And I actually am thinking about this one startup that I saw at this little sub conference, FutureNet, where Martin Casado was hosting this, and it was a lot of little network startups. And one of them had a sort of declarative network software where you would actually describe your intent in pure like English. So kind of like a tail F, except like a natural language process tail F, right? Where you just
Mhm.
go, oh, I want to have a global VLAN on my Sonnet ring that, is redundant and whatever you want to just, however you describe it, right? And it would come back and either go, okay, here's what you would do to your switching layer, your routing layer to implement that, or you can't because your layer one is wrong, but go do this, this, and this, and then we'll get there. What do you think about the kind of future of automation in that regard?
I forget. Well, I can tell you on my list of things to do is I want to go ask Chat GPT to write some code to link together because we just made this feature at work. I know this is gonna. I'm bringing it back to the real world here for a second, which is less fun. But we just did this feature at work where we do multi-cloud connectivity. So we have a cloud router, which is a VRF, and it will connect to AWS via its direct connect network product, and then to all the other clouds like GCP. Azure via ExpressRoute, all these things. And so we made a real simple integration where we configure the cloud side of the network too. So enter all the BGP
Yeah.
settings. The user just gives the IAM user an API key, and we configure the cloud side, all the BGP sessions, all the BGP information. So it just makes it a lot easier from a usage standpoint. You're not toggling between
Did you give
the
them all the options for that? Like on the Amazon side, do they get to pick VGW attachment versus direct connect gateway attachment or
yeah,
transit gateway attachment? And then,
yep, yeah. You get
and
to pick your
then,
gateway attachment point. Yeah, and
and
that
if they
like
do,
we populate that on our side with all of the available gateways. So the user just picks that.
yeah. Okay. And if they pick a DXGW, then do you, I guess when you're picking prefixes, the prefix filter is actually when you attach the VGW to the DXGW. So you assume if they pick the direct connect gateway as the attachment point, you assume the virtual gateway is just already attached or they'll do it on their own, or do you kind of two-phase that?
We assume. Let's see. What do we assume? That's a good question.
We're really out in the weeds, by the way. So
I
already
know.
was like, this is such a great conversation about the future. And then they're like,
And then all of a
what are
sudden,
these two
bam.
saying? Sorry, we've done some cloud networking. And so watch
Yeah.
out.
And
It's
so then
getting
we went
serious
straight
in here.
into so we went straight into cloud. Okay, so let's pull it back. Let's pull it back a little bit to stay focused on the prize here, which is the point is it's all about making it easier for the user, right? So you're not toggling between cloud consoles. And the biggest thing, like it's ridiculous just what you get wrong because you forget you typo the VLAN or you typo a CIDR in the prefix list. You do something. I inevitably always do something when toggling between two different consoles. And then I'm like, oh, why didn't this session come up? And then you go troubleshoot it. So anyway, it's taking that whole annoyance factor and time
Two
factor away.
transposed numbers are responsible for like more outages and failed deployments than like anything on earth, right?
Yeah, yeah. So I was thinking, I was like, I really want to. I have a note in my like ongoing notes from this week. I was like, I really want to go ask ChatGPT to write me some sort of integration. I haven't really thought of what it is yet, but I want to have it say, take the AWS API and the PacketFabric API and write some sort of integration for me just to see what it comes up with. Because that might be a really interesting point
Is
of
that as specific as you're going to get though? Write me some sort of integration, or
I
you think you'll figure it out and then ask for something more specific?
yes. I'm gonna
Okay.
figure out exactly what I want to do. I just haven't put enough thought into it yet because I want to start with something pretty simple. So I need to put a little bit of thought into like, okay, what would be a simple thing to do here? Write me an integration and then see what it spits back and if it's any good and it works, because that could be a real applicable thing in this world of services that we're at now, where everything has an API and everything's a service. If ChatGPT can reliably stitch together those services with some code, because previously you would have had to have coding knowledge of all the APIs that you want to integrate together to do this, which
Yeah.
is not trivial. And if you can have ChatGPT do that for you pretty quickly, there's a lot of cool integrated services that can be made fast. That's the most sort of practical thing I can think of like, how is
Mm.
AI going to change this API driven world?
I like really, I'm even thinking about a whole other level too, where I think the intent of what you want to get done still matters because I think we're still quite a ways away from going, what are the top improvements you think you can make with these APIs and having it be smart enough or insightful enough to really piece that together creatively?
Yeah.
Like, I think it would come up with some stuff and they would probably be things you could integrate, but they'd probably be less valuable than what you, with a lot of experience and knowledge and like customer experience and so on, would really pick. But I will say, right after the ChatGPT API was released, I was building this text to speech to text interface because I wanted to talk to ChatGPT because as soon as I started using the GPT web interface, I'm like, why do I have to suffer having like the Amazon version and the Siri version of this in my world? Can I just have GPT power everything? Because it's so much more intelligent, obviously, right?
Yeah.
Like if all those times it feels like it feels so painful to hear the Echo talking back to me with, according to an Alexa Answers contributor, blah, 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 blah. But it's like, it's still useful. And actually, it seemed like magic when I first used it, but comparatively for what you get from ChatGPT. Anyways, so I'm writing this interface, and the very first speech to text thing I used was this service at the time. They might have changed their name, called Eden AI. And it was like a front end for 11 back end services. But I'd never seen it. but I went, they had API specs, and I literally grabbed the open API spec and literally pasted in the chat window of ChatGPT. It was like, write me a class that will accept audio files, either byte streams or a file name that you can then open and read, and then call this API to convert speech to text and leave a spot for my API key. Worked almost one shot at it. So I mean, I had
Dang.
to paste the API key, but I got the class. Yeah, it was mind blowing. This whole thing I think would have taken me like 2 weeks maybe, because I'm a little bit rusty on the keyboard. I know what I want to do, but I'm still that person who I've written so many hundreds of thousands of lines of code, but I'm rusty enough that at least as of a couple months ago when I started doing this, might be true. I'd be like, oh shoot, what is list versus dict syntax in Python? It was
Mm-hmm.
that rudimentary, because like it's the thing you don't ever need to know because it's so easy to find out, and it doesn't really affect the way that you think about what you're going to write, and yet it's the thing that always tells you you're not a real programmer, right? Because you can't even remember this tiny
Yeah.
detail,
Or
and
you're
yet
not a real
suddenly it doesn't
programmer
matter.
anymore. Yeah. Like that.
Yeah.
That drives because I haven't written any real like practical code in 3 years now. It's like I still was probably doing there's scripts that I make myself and things like that. But whenever I go to do it now, it's so frustratingly slow because in my head, I still can kind of get it's like almost looking at things through fuzzy glasses now. Cause it's like, I'm like, okay, I know what I want to do and here it is. But then I can't remember some absolutely trivial piece of syntax. I have to look it up and then it happens again. And then it happens again. And you realize that you're severely out of practice.
Yeah, yeah, it's weird. And I mean, I spent probably 8 or 10 years basically where software engineering was more or less my whole job. And
Yep.
yet you look back, I think the last time I wrote code that kind of went into production was probably like 2014 or 2015, where
Yep.
I replaced an entire like billing system basically. But other than that, yeah, it's been a really long time. But it's interesting because this is the thing that makes you appreciate the value of experience. And I don't mean to say like, oh, you can't use the tool if you don't have it, but it's the thing that makes me realize I have such a clear picture of what I want from an intent and why that intent exists,
Yeah.
as opposed to the implementation was hard. Now I flip it around and I've actually seen, I remember interviewing someone for a software development role and I said, let's build this thing, right? And he sits down and I'm like, you ask any question, etc. He sits down and he starts coding and I'm amazed because just like right off of the bat, he's just fluidly like importing packages and just writing a ton of code and syntactically the code is working. And he seems so fluid. I'm like, wow, like this is somebody who's literally obviously doing this like all the time. And
Yep.
yet the funny thing is his implementation was definitely not optimal. And I was thinking the whole time, I was like, wow, he's doing it so well. He's doing the wrong thing so well.
The
Uh,
wrong thing's so right.
yeah. Yeah. And it makes you appreciate. I mean, it's like, I want to say this with like all the humility it deserves, right? Because like chat GPT is my crutch. It's like a little embarrassing, but on the other hand, it gets me excited about the fact that it becomes possible to kind of close that gap between intention and implementation a
Yeah.
lot, which is great. I mean, and I think at the end of the day, you talked earlier about people kind of becoming cross domain experts. And it means, I think if you're a software engineer, ChatGPT and the tools like it, Codex, et cetera, are going to probably replace a ton of the effort that you put into clacking on the keyboard to get the code when you have the intent clearly in your mind. But you're going to replace that with a lot more time, like understanding why you're doing what you're doing, listening to the customer, talking to a stakeholder, understanding the domain, right? Because we don't get software that drives cars and ships products just because we can solve a coding challenge, right? You can go solve the hard algorithm challenge. Doesn't mean that you really know like how the flow of processing a credit card works if you've never done it before. And there's
Yeah.
probably a million things that are like that.
Yeah, I'm sure, and it's funny because the whole idea of like intent-based networking that's been around for a while. I think it was a really big buzzword back in like, gosh, I want to say like that 2015, 2016 era, intent-based networking, and
And
we're
open
in
flow was like all the rage.
yeah, and OpenFlow was all the rage. That was the first SDN implementation of this is going to change everything,
Yeah.
and it turns out OpenFlow is actually really tricky, and so. Yeah, and it just goes back to the root of everything that we were just talking about in that it's really it's really hard to be both an expert on like conceptually, because it is sort of this wisdom with experience that gives you the ability to go, I know exactly what it is that I want. But then your skills are often so dull that it's difficult to do it, or your skills are so sharp that you can implement something quickly, but the picture of what you want is pretty fuzzy. And so it's such an interesting dichotomy there, because in order to produce something that is both, in order to produce efficient quality code that does exactly the thing that needs to be done, you need to have both of those elements. You need to have the intent very clear, and you need to have execution that is done in a way that is highly efficient. So yeah, I'm trying to think of like how having AI be able to write that initial code for you, and especially as it improves and does things more efficiently, that will allow people to just be even clearer on the intent and do that whole, to your point, do the whole cross-domain expertise thing, because then you can be an expert on 16th century Russian literature and not know anything about code and still manage to produce good, efficient code that analyzes every 16th century Russian work and looks for a particular word.
Yeah, being in technology, I bet happens to all of us, but I have the parents and friends who are like, can you help me with the X, right? And it's why does my phone do this thing? My computer gives me this error message.
90% of the time,
What should I
I don't
buy?
know. The answer is going to be, I have no idea.
Reboot it, reboot it,
Yeah,
reboot
reboot
it
it.
again.
That is, yeah.
Call support. Well, it's funny though, my dad has many times wanted to do something sort of technical, I think, right? And he was like, there was a time, I remember writing him a movie blog review site out of Drupal. It wasn't a ton of effort, right? It was mostly like
Oh,
install and download a
Drupal.
bunch of plugins. Yeah.
I haven't heard
This is
that one
old
in a
school.
while. Yeah.
Yeah. I think it's still around, but I mean, this is circa like 2000, maybe 6, 7, right? So this is when Drupal was really having a heyday.
Yeah.
But
I still love PHP. Don't get me wrong. I was not a big frameworks person, but I wrote a lot of PHP. So
I wrote a lot of PHP too. I mean, we actually used it for some of the customer front end stuff at Exodus. Like, and I wrote remember writing a translator that would pull all of the checkpoint config files, and it would log into the Cisco Pixes and actually dump. It used a screen, like an SSH plus screen module in Perl rather than Python.
oh yeah,
But would ingest,
Perl net SSH was
yeah,
the best. It was the
yeah,
best.
that was like, there's so much. I bet there is a mountain of automation baked on that nowadays. People still today, even at Pax, are like, yeah, this thing, and we're not just the API on this is a little sketchy. And I'm like, well, let's just go get it from the console. Like, because I'm thinking you guys have never dealt with net Perl SSH, right? That's how we did it in my day, and get off my lawn,
Mhm.
right?
Hey,
But
it is a tried and true. It's funny because we're looking at some extreme equipment right now, automating that, and they don't have an API. And I was like, back to
they
that,
do have an
back.
API.
They do really? Why
They
couldn't I
do.
find?
However, seriously, and I'm pretty sure I can just say this, but there was a time where we actually had a workflow that it matched what we did on the CLI,
Mhm.
matched what we automated against the API, and we tested the API version, and it worked fine in all of our test dev. When we finally rolled it to production, the moment we rolled it to prod, it crashed the switches because whatever was implementing the API had some kind of memory buffer problem, and it would
Mm.
actually go and then the switch would die. And I don't know if it needed a hard reset or what, but it was like, I just remember getting one of these really cranky CEO calls, like the automation just caused a prod outage, and I'm like, this has been tested more than anything we have ever tested in our entire lives. But this just goes to show the flaws in like testing. We were
Yeah.
testing in a lab of our, we did all the use cases. Our test coverage was awesome, but we didn't test it 100,000 times. And when you start doing it at prod scale, the same thing actually happened at VMware.
Testing anything at scale is hard. Like,
Yeah. And it's always the memory things, by the way, like vShield Manager back in the day. I mean, those early days of VCD, the Blue Lane appliance that VMware bought that became vShield Edge and vShield Manager. There was there was some integer that was like about which API call you were on, and it was only like a 16-bit integer. And so on the
oh,
65,536th API call, which by the way, VCD was just making them in the background, so you were going to get there at some point, no matter what you did. But on the 65,536 call, it would stop responding like completely and need like a hard reboot, basically. So yeah, unbelievable the way these funny things like creep up on you. And again, it's one of those things, if you tested it, quote unquote, in real world conditions, but this ends up being like, how do you let it run for months? How do you hit it with tens of thousands of calls? The being resilient against these like kind of unexpected errors is really tricky.
That's why we developed this was back in like the prolexic days, because we had Ixias to generate just a huge amount of traffic, because when you're dealing with DDoS, you're always dealing with brand new conditions, brand new attacks. You're always dealing with some bit and some header that you've never seen before, because there's a program on the other end that is sometimes writing these packets and sometimes accidentally malforms them and all these other things. And so we always would say production is the best lab. It's always been the best lab.
I don't always test my code, but when I do it in production.
Kind of production.
So yeah, I need a Heineken when I say that.
You absolutely do. And it's
wait, it's Dos Equis, sorry. Apologies to the most interesting man in the world.
Yeah, I forgot about that guy. That is a great meme.
Especially for that.
Yes, it really is. So, and it's funny, it's like when we talk about all this lofty pie in the sky sort of stuff, but when are we going to actually be able to test things reliably? Like, isn't that sort of step number one, that we stop using production as the best lab? Like, when is that going to happen?
This reminds me too, because I had some folks that I worked with at VMware, and they were very into the intersection of like lambda calculus and functional programming, right? And having code that you could prove, even from a mathematical sense, that like this will always run correctly. I mean, obviously it doesn't account for things like, okay, you used non-ECC RAM and something coming from the sun knocked an electron loose and flipped a bit. I mean, there's no accounting for that stuff.
Ray?
Cosmic rays, the Fantastic Four, and your error in production, both the same cause, right? But the thing it's most dramatic to me when juxtaposed to automation, because the thing they'd always say is, well, you don't want to create side effects, right? Like the idea is input equals output over and over and over again on any given function. And I think there's some interesting evolutions in functional programming that I've seen in my tiny bit of spare time that I've dedicated to keeping up with this, where I saw a language recently that kind of tries to implement a lot of the good things that a Scala did, but it tries to be very declarative about things with unknowns, where there's unknown types or unknown side effects. Like it has a specific whole set of, I don't want to say patterns for dealing with less known things where that doesn't apply. And that dirty world, though, that's what automation is. And I was thinking about all those like net Perl SSH. It's like those things end up being like 20 lines of functionality and then like 1,000 lines of error catching, right? Anything and everything can go wrong.
Yep. Yeah. That is so true too. Yeah. Because you have to account for every single error that might possibly happen when you're just reading input like that. Yeah.
Some of which you don't know, right? There's known unknowns you test for, but then it's even like, how do you test for the unknown unknowns, right? And if you grow up in the world where you're automating things, don't you end up frustrated though when you get like some random Java stack trace and it's like it doesn't even really explain what's happened? You're like, listen, why did you just fail an assertion and failing the assertion through an error as an exception? Like, can't you do something with it? Like you were testing for it. Assume that it fails. Now do something rational, not just like throw up and die, right? So,
failed successfully.
Yes, failed successfully. Check. Another test passed. Well, so maybe AI helps with this. Like one of my old peers back at VMware now runs a company that does AI generated test coverage. I'm actually hoping to have him on at some point, because he's been there running that company like 3 or 4 years now. And that's like so before the GPT moment. Yeah. Nowadays, of course, I literally think about this automation conversation. I go, I wonder what happens with a GPT-4 when you go, here's a functional script. It does what I need it to do. Tell me, first of all the things you think it does, and then write me every possible, every test for every possible error condition. Yeah. Everything you can think of, right? And it's such a big domain Like the one thing about doing this, I think that you probably agree with is just when you think you've got everything covered, there'll always be some weird thing. Oh, yeah, this installer doesn't have the permission set correctly on that thing. And oh, and memory error. Oh, look at that. The number of cores on the processor's not divisible by 2. And therefore, I mean, just a million dumb things. And something always manages to go wrong. I mean, you get hardened, but it's never perfect.
No, I like the idea. I actually really like the idea a lot of asking GPT-4 to basically become your QA. I wonder, like, I want to do that test now along with my integration test just to see what it comes up with, because that sounds really fascinating.
Let me know how it goes. I actually have had good results feeding it code and going, if essentially harden this, optimize this. What can possibly go wrong with this? What's assumed by this? Because it's kind of a very analytical thinker, I guess I'd say.
Yeah, yeah. This always reminds me of my favorite joke whenever we're talking about QA, because I'm a horrible QA person, by the way.
Oh,
So it's like, so
I am the
QA.
technical debt.
That's definitely not my role in life. QA engineer walks
I'm really
into
good
a
at rapid
bar.
prototyping, though.
Yeah, so rapid prototypers are typically not the QA testers. So
I
it's
need a
the
pair
it's
programmer, and GPT volunteered.
yeah, it's the QA joke. So a QA engineer walks into a bar, he orders a beer, orders 0 beers, orders 9,999 beers, orders a lizard, orders -1 beers, orders a string of random text, orders all this. First real customer walks in, asks where the bathroom is, and the bar bursts into flames and kills everybody.
Oh my god, I
Like,
haven't heard that, but that's pretty
really?
good.
I love it.
Yeah, I haven't
Now
heard
you
that
got a
one.
new, yeah, now you got a new joke.
That's so real too. I mean, it
Yeah.
actually reminds me of that little quip they used to hear. This is like 20-year-old quip, right? Where they go, if Microsoft built cars, by now they'd get 1,000,000 miles to the gallon, cost $100, ride smoothly, drive themselves, but explode once a year, killing everyone inside.
It might be worth it. I mean, I don't know. I like that actually doesn't seem like the worst deal.
Roll the dice.
Yeah. I mean,
Yeah.
Teslas do in fact burst into flame, occasionally burst into flames and kill everyone. So, and they don't even do all that cool stuff. So,
Yeah, they do some cool stuff though.
yeah, I do.
I've been
Do you
on
have a
I've been
Tesla?
on I do. Yeah. Well, my wife does, but
Okay.
it's kind of the family car.
Yeah.
But yeah, I've been turned on the FSD beta now for, I don't know, it's like 16, 18 months. Yeah, since the days when you had to have the perfect driving score, and I drove like perfectly fastidious, and I was like, honey, why is this following too close alert? You cost me 10 points. It's going to take 2 more weeks to get eligible, kind of thing. And
Yeah.
then I got it going, but it was terrifyingly bad when I first drove it. I mean, doing all kinds of weird things like crossing the wrong lane right after it turns into a parking lot, and
Oof.
just proceeding straight from a right turn lane. And of course, like, I'm not counting on it to be sane. And so I pay a lot of attention to it.
Yeah.
And so it's safe because I actually trust it. It's probably safer for me than the cruise control my Volt, because I have a Chevy Volt too, and it's got an adaptive cruise where
Yeah.
it uses radar to like pace the car. If the car in front is dead stop, it will come into a dead stop. But sometimes it's been a little close, like where it's like doesn't start braking soon enough, and it brakes really
Oof.
hard, and you're like, oh boy, I don't even want to step on the brake now because it's trying, and I might mess it up because it'll disengage. But I'm like terrified I'm going to hit the guy in front of me,
Oof.
and it never did. So hooray! But in some ways, because I trusted it more because it's such a quote unquote simple system, I think
Yeah.
maybe in some ways it's riskier. I had a friend though who literally had 10 years of Model S and would drive down the freeway, wedging his iPad against the steering wheel and playing games on the iPad while on the freeway. Not generally at like super freeway speeds, more like traffic on the
Yeah.
freeway, which is probably the safest case to use it because everything is so straight. There's nothing to do. You're following a
And
car
it's
in
so
front of you.
structured, you're just going, it is accelerate, decelerate, accelerate, decelerate, or accelerate, stop. It is
But
a
it did get
very,
into an accident. No,
well,
it was technically the other person's fault, but it did happen while he was on not FSD, but on autopilot, not paying attention. The guy just cut in and didn't yield. And the car wasn't like 100% clear on like, okay, I think I get to keep going. And it didn't realize that its front corner was going to hit him. And so it did hit him. So that guy ended up having to pay for it. But still, I'm sure friend wishes he was looking up at that moment and could have averted the accident. So
Yeah. So
some of those
what do you
cases
think
are,
about self-driving cars? I'm really curious about this
yeah,
because you're a huge AI proponent. What
yeah.
do you think? When do you, or I should ask more specifically, when do you think we're going to get self-driving cars?
Depends, but I mean, obviously, like the powerful level 2 systems are here now, and I probably as much as I'm really careful with the FSD on city streets, I probably have done more slightly risky driving on freeways than anyone would want me to. I think real level 3, where within the confines of many places, including certainly the freeway at lower speeds where you can be unattended. I think it's going to be here literally in the next 2 or 3 years. I mean, and
Hmm.
it's shipping now. Like Mercedes has a car. No, sorry, it's BMW. The BMW 7 Series or 8 Series is going to get level 3, a very limited level 3 self drive, like on this next model, if it's not out right now. And Toyota has a car in Toyota that is also level 3 enabled, but it's super restricted to start. It's like only works on the freeway, only when speeds are less than like 37 miles an hour. So
Mhm.
it's literally the gridlock avoider. It's still like a killer app, right? Like,
Yeah.
is there more of a miserable time to be in your car, right, than driving
Yeah.
in gridlock on the freeway? But I think getting to level 4, hard to say. I think it depends a little bit on what happens with things like LiDAR, or will it follow a progression, or will we see just better image recognition models? When Tesla began this journey with their self-driving stack, I mean, okay, so Google shipped the attention is all you need paper that introduced the self-attention mechanism for transformers, which like revolutionized so much of ML in 2017. So everything since then, like, yeah, something like 80% of all like big new interesting ML models now, I think are based on transformers in some way.
Mhm.
And I feel like Tesla literally had fully functional kind of FSD, at least on the freeway before that, right? So, I mean, you have to admire how good they made it when they had essentially junk hardware with no LiDAR, kind of junk software in so many ways. I think we're well on our, I mean, I think there's a ton of improvement that will happen. And to be fair, like I went to lunch today with my wife and the car drove me across town and I didn't intervene at all. So I was like, navigate to the sandwich shop and I kicked it in and it drove miles and miles and made right turns and left turns and yeah, everything. And it was totally fine. And I've got my hand on the wheel and I'm paying attention, but I'm paying attention to that like very relaxed, like I expect it to do certain things, but it's like doing it all for me. It's kind of a nice way to drive. I don't know if it's $15,000 nice because I mean, it does not change the driving experience, right? It does
Yeah, you
make it
still
so you
have to
can be
be
lazy.
constantly engaged, and
You
that's
do.
part of that's
Yeah.
the thing that we're looking to solve. I
Right.
don't know. I think
I
that
want to have a desk in my car for sure, right? Or whatever we
that's the
call
whole
it.
point is you could use driving for other time. Driving becomes a lot like sleeping. It's a period of time where you're unable to do other tasks that would be
I probably
much
would
more
sleep.
productive. Yeah. Yeah.
Yeah.
I think level 4 is gonna take a lot longer than anybody else thinks. The most practical application that I keep coming back to, especially for like a level 3 oriented system, is long distance cross country trucking. Because that
Well,
is
I think that's going to be the first level 4, literally for
you
sure.
think so?
Right.
Well,
Oh yeah.
because I don't think the trucks well, okay,
Well, sorry, I
I
don't know
guess
if
it
it's
depends on how you
trucks.
define
I think
levels.
freeway beats city, right? Because there's just
Yes.
so many less variables for
Freeway
sure.
trumps
Although,
city by a lot.
I mean,
Well,
have you seen
because
the cruise cars drive around?
I have seen those. And
I mean,
they look like they're doing well, but they're also surrounded by almost entirely human drivers. It won't be the case in
sorry. So,
in
oh,
these like
yes, surrounded by human drivers. Well, so
yes.
this is something I think that as level 4 reaches reality, I think something in the context that, but let's take this back to networking, right? I kind of feel like for several years, actually, maybe as long as like 6 or 7 years, there's been like edge has been like a drumbeat.
Where
And a lot of it,
so tell me where is the edge? What like I love this. This is like the fun question. So where is the edge right now?
well, I usually categorize things in like near edge, far edge, right? So to
Mhm.
me, near edge is like all those data centers that aren't near cloud, right? Like everything that's being operated in Denver and Utah and Portland that's not in the cloud area and Minnesota and whatever, right? And I was at VIA West for a long time, And one part of the game plan was build and operate the best data centers and have the best service in all those secondary markets. There's not going to be a Virginia, et cetera, et cetera. And I think in terms of proximity and getting out like roughly adjacent to some big portion of users, that's useful. But then I think the far edge is everything else. It's the truck, it's the sorting facility, it's the cars, it's the whatever, it's the farm, it's a million places. And the problem is like what I think everybody really, the hype for me was 5G is going to change everything.
Oh,
And then later you're like,
yeah.
sorry, how does 5G change
Has
anything? Because
anything.
it's not a far edge technology
No,
because
no, it
it goes
actually requires
1,000
things to be even
meters or
closer.
something, right?
Yeah.
Yeah,
Yep.
exactly. So it's like, it's a ton of bandwidth it's basically a wire replacement for like dense markets instead. Or I think the whole idea of private 5G or Wi-Fi 6, something along
Oh yeah,
lines to
5G
enable
in the office
campuses.
buildings. Yeah, office buildings, factory floors, things like that. It makes a lot of
Yeah.
sense, but outside of that, the economics get just really goofy really
Instead what we need
fast.
is really tiny amounts of bandwidth on really low frequencies that are powerful, like the submarines where if it like sank to the bottom of the ocean and the ballast was broken, it could actually still send like 1 bit of Morse code per 10 seconds, like halfway across the planet, right? Those kind
Huh.
of
I
ultra
actually
low
didn't know that they could do
frequency.
that. That's cool.
Yeah, there's something about you can read more science, more Michael Crichton and what's that other guy who writes all the Hunt for Red October books, whose name
Oh
I'm
yeah, yeah,
just totally
yeah.
forgetting. Tom Clancy, right? But you read more Clancy and Crichton, and then this stuff happens in those. But yeah, I think maybe that's what some of those devices need, right? Because all they have to say is like, it's this temperature, and I'm okay, like every hour or something. But you really want no connectivity on that, and actually LTE is kind of a junk solution for that. I mean, in the sense that it's way
It
more
works.
throughput than you could possibly need,
Yep.
and it goes, and what you really want is distance, not throughput, right?
Yep.
You
Well,
need
what you really,
reliability probably
yeah.
sometimes.
Yes, you need distance, you need reliability, and you need a decent throughput, which for what the applications are running today, LTE provides that. It may not be the
So,
case in the future, but it works enough for now.
so let me link the network question and the edge question with something that aligns with my original self-driving car vision. Let me ask you how we get there. So a long time ago, I did this like, economic calculation. There was like $600 billion in energy savings, but my vision of self-driving at the time was like a whole fleet of cars like drafting behind one another, doing 100 miles an hour, where fleet level coordination would have whole batches of cars like slow or speed up. So there would be no stoplights. You just zip
Yeah.
through. And if you were going to collide, your cohort or whatever you want to call it would slow down to let the other one pass, etc. So I still think maybe there's a chance that on some level we're going to force some kind of self-driving car protocol because of exactly what you said. There's a bunch of human drivers. If at some point you want to make the cars have this higher bandwidth, more useful communication where they could warn each other, there's a pothole ahead, or my camera is blocked. So I'm going back. I'm going to take myself offline, but let me get home first or whatever. What does that take from a network perspective? If we assume there's like literally millions and millions of vehicles and they're all over the place and roads stretch all over, and if somebody said, and design the network for the self-driving car fleet of the future so they can go anywhere there's a road, maybe including dirt roads, how do you approach that?
This is where I think everybody gets wrapped around 5G and maybe doesn't really understand it. But this is if you had a 5G radio in every car where they could communicate with each other and then also enough processing power, the problem comes in when you have to make any sort of call back to any sort of central computing type system or intelligence to make any sort of decision. That's a huge problem from a network perspective because the amount of data and the latency upon which you need a response to that data is unrealistic because the accidents happen in fractions of seconds. And not to say network traffic is still moving at the speed of light, at least once you get it in fiber, but that's really not fast enough. The edge still is not ubiquitous enough to service anything like that. So you have to have like all the decisions and everything have to be in car. So really the best case scenario is that the cars can accurately communicate within to every car within 1,000 feet of them, or maybe even a bigger area than that, because that's the only communication that matters, is that real time for your direct area. It would be nice to know, and it would also be less time sensitive to know what's going on a mile up ahead. What does the
Yeah.
congestion look like up there? How do I plan for it? And that's something you could do. And I mean, that could probably be handled right now because you're talking about a much smaller amount of data potentially, maybe just sending the car speed, for example, back to somewhere central. So there can be a central idea of congestion like Google Maps does now. That's a low amount of bandwidth. That could be handled over 4G like it is now, but you definitely need high bandwidth, super responsive car to car systems, as well as enough compute power and intelligence in that car to handle everything that it's receiving. And because your immediate area is the only important one. I mean, you have to know something about what's coming up, but it's not a lot. Your safety is only dependent on your immediate area and how you're going to act. And so, yeah, that's actually like that is the case. I think for 5G communication is car to car.
That makes sense. Yeah. Did you happen to catch that video? There was one where the CTO, I think, turned CEO again of Cruise, Ken
Oh,
Vaught, I want to
Kyle.
say.
Yeah.
Kyle.
It's
Thank
It's
you.
Kyle. I
Yeah.
actually knew Kyle back in the day. So it was Kyle, a couple friends of mine, Kyle and Jonathan, that started Justin TV. This was,
Oh, I did
yeah,
not know they were involved. That's cool. I literally was just,
yeah.
I was just listening to something about, God, I started listening to an audiobook and the person was talking about being involved. So I guess they were in the early Twitch days. I can't remember what I was listening to
Yeah,
now all of a
that's a
sudden, but
Justin became
yeah.
Twitch, and so,
No,
yeah, because
yeah.
this is back when I mean, I haven't talked to him since he joined Cruise or anything like that, but this was back in the day when they were trying to figure out what was gonna be Justin TV, and people had their own channels, and then everybody started to get really interested in the people who were playing video games. So
Yeah.
that's how Twitch came about.
It's so amazing how many hours get logged to it now. But so before the GPT moment, um, Kyle, sorry, there I go. Kyle and Sam Altman from OpenAI actually did a
Mm,
little 45-minute session on YouTube. And it basically was Kyle showed Sam like compressed hour and a half, but like it was going at high speed, sped up most of the time, footage of a cruise car driving all around. And Sam was kind of doing a lot of, oh, wait, hold on, go back. Like this thing that it did. And one thing that really struck me, that was a really interesting conversation in that video, was Sam asking basically about the car as it went to make a left, and there was a driver who was coming up to make a right, and it started to turn before the intersection was really clear, right?
hmm.
And that's something a Tesla would never do, right? Just my experience with FSD beta is it's paranoid about being in an accident. And so in congested situations, like it wants to make really fast turns when it's also really safe, right? So it wants to wait for a bigger gap than a human would, and then it wants to accelerate faster than we probably would to get out into a safe spot quicker
Hmm,
than we would.
hmm.
But Sam asked Kyle about this, and there was an explanation that there was some human behavior, but this is the really thing that really blew me away, was that there were things they had started building into its driving persona, if you will, that were human-like, where it would do things like start to slide over it, signal and start to move over as if it was going to go into a lane, where it
Mhm.
really wouldn't. Like it wouldn't force itself in because it was too tight. But we as human drivers know that a lot of times, if we get right up to the edge and we're acting like we're just going to jump in there, that a person behind goes, okay, I
Goes,
can't
"Ah,
really cut them
fine.
off. I'll cause a
Yeah, I'll
wreck. And
let
they
you
kind
in."
of,
Yeah.
and so they're actually programming a certain level of aggressive driving of the car because it's part of our sort of nonverbal communication driving to say, I'm coming in, right?
Yep.
Whereas, of course, we've all been in those places, some are worse than others, where you put your signal on and you're trying to be all courteous. The person who's like 3 car lengths back suddenly wants to go 15 miles an hour faster, right? Because you've signaled because you're going to get over. And if you're not zippy about it, they want to just get in front of you before you change lanes or something, even though they weren't even going faster. So I guess it was kind of a really interesting thing. I don't know if you caught that, but I think that's a really interesting thing that then goes away with networked cars to at least between each other.
Well, that's the thing. That is the crux of the problem, I think, more than anything, is human drivers uh with self-driving cars, whatever you want to call that, whether you want to call it AI or machine learning or whatever you want to call it. So whatever becomes self-driving eventually is Because if you just had self-driving cars on the road, it actually becomes a really easy problem. Like whether or not they can communicate with each other over high bandwidth or even a little bandwidth, you can probably send enough data to make it very orderly and very easy. But humans have a whole nother system for driving and a whole nother set of rules, which we spend a lot of time learning. And those aren't the rules in the DMV handbook. It's the rules of the actual experience being on the road and seeing how people behave. It's like there's actually a body language in cars and tell if someone's an aggressive driver or a timid driver, and you can adjust your behavior accordingly. So I think that that's really neat, actually, because Cruise kind of seems to be on the right track with that, because that's the only way a self-driving car could fit into a human driving society is to understand the behaviors of the cars around it and actually have its own behavior, whether that was more passive or more aggressive, and being able to address that situationally too, because sometimes it is much safer to be an aggressive driver than it is to be a cautious driver.
I haven't thought about this a lot lately, so this actually is a really interesting place that it goes to. But I almost would be willing to bet money that after we see a pretty reasonable adoption of level 4 self-driving, where there's still a mix of humans, and there is legitimately a works under most circumstances for most people robo taxi service. I've been listening again to Future is Faster Than You Think by Peter Diamandis, and he's got a lot of interesting predictions there that are pretty big on the transformation. And I agree with all of it in principle. The timing has always been the question, but I would be willing to bet that once there's a certain critical mass of level 4 and there's a robotaxi service, that people move to legislate human drivers off the road in
Yeah.
most places. Like not
Oh,
everywhere. You're still going to be able to go off to little used roads and drive, and all the cars will be ready for human drivers there. But I think if you're in anywhere in a big city, probably radiating out to like a good 45 minutes or an hour worth of suburbs, plus all the freeways a lot of the time, I think we'll ban humans, and it'll be because they cause way more accidents.
yep.
So it won't just be
Oh,
them. It'll be putting lives at risk. And people stop owning cars because with a self-driving car fleet, the cost per mile to just have the car come pick you up when there's an entire fleet of things that drive themselves, like why would you own a car anymore? It'd be this enormous like 5-figure, 6-figure capex investment that makes no sense for the number of miles driven, right? Like there were already people who, with a modest amount of driving, were already like, you know what, I switched completely using Uber. Here's what my life is like. And it's mostly journalists and experimentalism and things. But it was like you could be real clear that for a lot of people, it was pretty close. And in a world where you can seed cars better algorithmically and there can be more of them because idle is less expensive because you're not paying a human being, right? I mean, the cost of a car sitting there waiting to pick someone up when it's electric and it's just sitting on a charging pad or whatever is near zero.
yeah.
And
Yeah,
then we
the
get
human
all those
driver.
benefits.
Yeah, the human driver in any car service right now is still the big challenge to overcome, because they're the ones who are the bulk of the costs. They make up for the bulk of the issues, whether that's delays or going the wrong way or whatever the case may be. So yeah, I 100% agree with you that that is going to be the future, is that human drivers are going to be shoved off the road because
Unless, of course, we have all those AVs, right? Because there's all these. I mean, Peter Diamandis is also talking about this in this book, right? Too, which is there are a whole bunch of projects for essentially unmanned robo sky taxis instead, right? So just bypass the car problem completely, 6 and 8 rotor things. Archer is one of the companies that's doing one of those vehicles that United invested a lot in and kind of pre-placed an order for 1,000 of them a long time ago. And they just announced that they're expecting to start service. And I want to say it's like Chicago to New York or something, or it might be JFK to LaGuardia or JFK to downtown in Manhattan or whatever.
JFK
Like
to
one of these
downtown
little,
Manhattan, that's a server that I would be there. That's a service I would
yeah.
be into.
And it's, yeah, I mean, and so it's a flight thing. And I think they're still trying to hash out all the details of like what altitude can we fly at and how do we avoid collisions? I mean, classic air traffic problems. But they're saying, I think I'm going to say 2025, they're going to have a route like actually active with these things.
Wow.
The idea of flying in an unmanned robo helicopter, effectively, or robo drone, whatever you want to call it. I mean, I think they say eVTOL is the term that they like to use. Electronic, again, they're all electric too, by the way, right? This is all, there's no gas and fuel. It's all electric motors. which I think extends the life massively on the vehicle, which helps again with the CapEx problem because you could fly flights on the thing for 40 years maybe. But I think the benefits of the self-driving car becomes what happens when you can get to work with, there's never, ever any traffic because there's never an accident. There's a perfectly coordinating
Better
fleet.
yet, why are we
And
still going to work? That's the better
yeah,
question here. Why?
yes, that is an interesting question. Yes. And we even, hold on. Amanda, edit this because I just blurred myself in the middle of a sentence. But yeah, the question about like the remote stuff is interesting. And we went back to the office post COVID. We actually kind of let our lease go on the place and open it up. And I'll be honest, I love having a place we can go to, and I love being in and working with people sometimes in person. But I also am a huge detractor for the office as a mandatory thing because it's there.
Yeah,
Although, let me ask you this: I don't know if you guys even have junior people, or if you kind of
we do.
actually I did a network panel with one of the guys that was running, like, one of the lead architects for Yahoo's network, like literally one of the first conferences I ever did in like 2013. And somebody asked, like, how do I break into, you'll be so proud of me, actually. They were like, how do I break into networking these days? It seems like there's less and less roles for junior people. I'm like, I'll tell you, learn to code, learn to use APIs.
Mm-hmm.
Okay.
And
But what were you going to
yeah. Oh, I was just gonna say, yes, that is exactly the right way. And it's because it's almost becoming okay, granted, I am definitely on the I would say more on the cutting edge on this, but I think it's much less cutting edge, is that it's a prerequisite now to have some experience in Python, understand the basics of working with network APIs to do things. Uh, that kind of seems like where the industry is, at least from my perspective. And yeah, we do have a ton of, I know the question that you're driving towards, which is how do especially junior people get into a remote environment and succeed?
Exactly.
Yeah,
Yeah.
and we've had a huge amount of success. So we have junior people on both the network side and the software side. And they're some of our best people by far. We actually have this one junior in the on the code side who's just produced some incredible work lately, and they're pretty heavily mentored. And it's funny because I know I read there was a study by, I want to say it was Google. I could be getting that wrong. There's a study by one of the big bangs that basically found that
M- Meta did just have
oh, it was
one that
Meta.
they released.
It was Meta.
Zuckerberg was like, we have studied productivity in and out of the office, and the
Yes.
people who come in are more productive. And I'm like, I want to
I
see
I
the
wonder how
methodology
self-serving.
and
I feel
yeah,
like it's very self-serving because the bent on it was very interesting too, because they said very specifically that the people who suffer the most by not coming into the office are the junior people and
saw that too.
disproportionately women. And so I really want to know what this, they said that women got far fewer PR reviews and all this sort of, I don't know, I was like, that just seems bizarre to me. Like that I agree with you that
Mm.
I really want to see the methodology for that because we have both men and women as juniors and they both really excel. We have some amazing seniors that do very in-depth PR reviews, which I mean, if you're doing a PR through GitHub, I don't really, for me, it's hard to grasp the difference between what you're going to write in that PR, like whether you're sitting next to the person or whether you're not, and any follow-up conversation. The only difference is if you're sitting next to them, you might go, hey, I just sent you something. Let me know when you have time to talk about it, which via Slack, you might just go, hey, I just did a PR for you. Let me know when you have time to talk about it. I for me, it just doesn't, not a lot of that rings true because I've been doing remote work now and had almost entirely remote companies for 20 years, like long before a lot of the technology that we had today even existed. And the communication has just gotten better. I think it has really improved from just pure IRC communicating, which is what we used to do. Yeah. It's
I love it.
all in IRC to going to, we've been through various iterations of as AIM and then Slack now. But you have video calls that are super easy to jump on at a moment's notice. And you have, not to mention that, you have all these. So you have huddles on Slack, you have Zoom, you have your traditional mobile text, you have Signal, You have WhatsApp. I mean, you have people like it's literally you cannot go to an app and not have a way to communicate with them. And
Yeah.
so I find it very challenging to accept that the only way to really get good collaboration is in office. And it's not that I undervalue having, sometimes it is nice to get together with people and have a collaboration session because, especially if you're brainstorming an idea, there's something to be said for like an energy in a room when you're
For sure.
thinking of ideas. And it's great to be with people and see all of their body language to see how they react to certain ideas and things like that. Because there is actually a pretty good reputable study out there that just seeing somebody from most of our nonverbal communication actually comes from cues that are below the neck. Like 90% of them come like from hand movements, from subtle body gestures, how people are sitting, how they're positioning their feet, all that, which you can't get on
What
a
color their pajamas are.
what color my pajama. I actually have dogs on my pajama bottom. And so there's all these subtle cues that you don't necessarily get, which is great when you're doing really in-depth work, but for not every bit of communication requires you to have that's like the super high bandwidth communication, right? Do you need super high bandwidth communication with somebody to drop them a note that says, "Hey, can you go and pull me up this report?" No, you don't. You don't need that at all.
Actually, this is a place I think where even the thing like Slack voice and Slack audio is kind of interesting. Although, arguably, I feel like sometimes it's easier to say it, but also easier to read it. I don't know if Slack can auto transcribe the voice notes. I
Mm,
will say OpenAI's Whisper API seems pretty incredible for speech to text because I run a lot of text through it now, and it appears marvelously competent, especially compared to things like the auto-generated captions and stuff, which I feel like flub every fourth word when you're in technology. And I felt like it
but
was
they
doing a
make it
much
really interesting.
they do. But sometimes HR violations in the captions, right, is bad, but totally no one's fault except the ML. But I do kind of feel like the set of tools is insufficiently adapted for remote work. And I'm not saying this as a say we shouldn't do remote work. I'm saying I actually have a hard time dealing with the fact mentally that we had this enormous pandemic where so many people shifted to remote work en masse. And we all talked about how everybody was adopting tools, but we took the tools we had pre-pandemic and Zoom didn't change, Slack didn't
Yeah,
change. They were the
yeah.
same. And I would have thought we'd have gotten something like a flow doc, but like times 10, right? Where everything was like, there was a big canvas of activity and I could kind of see what people were doing at all times. And like, there would be like an ability to kind of understand on a low grade, like, is this person really concentrating or like, there's a great thing for ML, right? Could I please just have ML that indicates somewhere in my workspace, whether it's Slack or otherwise, like he's doing something where he really shouldn't be interrupted. Like he's in the middle of writing, he's in the middle of coding, whatever, versus he's just shooting off emails. Like go ahead and interrupt, right? Or he's typing to people on Slack, go ahead and interrupt. This is a great time, right? That is alone. I mean, I am a huge believer, and I'm sure you are too. I'll put words in your mouth, right? Of that whole, all interruptions are significant, right? Everything is
Yeah.
minimum 15 minutes. If you take somebody out of the zone and like, it just, can I please
Yeah.
have some zone protection ML now? Actually, startup idea, but I
I
mean,
know, I know.
really.
I'm actually sitting here, I'm like, that's not bad. That is not bad. That actually sounds like just a Slack plugin that I could probably have Chat GPT write for me tonight is to have a little status setter on there that will say exactly what application you're on.
Maybe not even that, because I think people really want, like, I think one of the problems about like intrusive monitoring is people want some level of privacy. Doesn't
Mm,
matter who owns the computer or whatever, right? If somebody decides to forget about it and spend 15 minutes reading Reddit, or they're having a weird conversation about their mother-in-law over the messages app or whatever, like, please IT don't be watching that, right?
yeah.
And on the other hand, as much as that is, I'd love to have something that was intrusive enough to kind of help people understand what I was doing when I was doing it and integrate my workflow with their workflow
Well, you can
while
bucketize that
protecting my
though.
privacy.
Yeah, you can bucketize just the applications into
Totally. Yeah,
saying
yeah.
like into different like love priority levels, saying like if I'm doing email, low priority work, like
You got it.
however yeah, low priority interrupt. If I'm in a console window, probably doing some high priority work. Don't
Okay.
touch that. And
So now if we feed this to ChatGPT 4 and ask it to write this MVP in a week, some Google ads could be viral in a month. Next thing you know, will be bought by, well, maybe by Salesforce in a 3 months time frame. We'll give ourselves 3 months to get bought here.
all right, I like
Sci-fi.
this. I like this. Yeah. So anybody who's going to listen to this, get in now on the ground floor if you want to invest in this, because we're aiming for acquisition in 3 months.
The other day, a VC that I know from just some previous lives, there was a guy who posted this thing. He'd written a Mac integration for GPT, right? Where you copied a certain string into your clipboard, and if it saw double at signs, it would feed it to GPT and then return the response to the clipboard. And the VC replies, "Where do I wire you $10 million, $100 million pre-seed valuation?" It's
Yeah.
just like, it was a joke, but it's like reflective of this funny like frenzy that seems to be building. And yet this is the thing that I love about this. And I was going to ask you this really near the start. Like, do you think that this might be the moment, all this stuff around AI and ML, is this the moment where we one up the internet? Because I think that was basically the biggest game changer for like the inflection, the curve of humanity's progress that's ever been. But I think we're going to outdo ourselves now.
Yeah, I think this is another huge jump point, but the problem, and maybe it's the jump point that gets us to the next jump point, because the next jump point, I don't think is until something really fundamental has changed about compute. Moore's law, it's like, great, we get more processing power and we keep figuring out how to put circuits closer and closer together on chips. But eventually we are going to reach we're going to reach some sort of fundamental physical limitation there. And so there's got to be an underlying change, whether to some other sort of compute medium. And I don't know what that is exactly. It could be biologically based. It could be based in a different type of physics. Like,
Bits,
well,
maybe.
yeah, it could be.
I think about, I mean, I am feel woefully ignorant about what's really going on in quantum computers other than the whole anti-cryptography fantasy part of it.
Yeah, well,
But
we can talk any I am too, and that's why I'm hesitant to talk about it, is because I got really into quantum computers when I probably just out of college. I was like, "Ah, this is gonna be the thing someday." And I know it's advanced, and that could possibly be it, but there's gotta be we're gonna hit some limitations, and there's gotta be a fundamental underlying change. And it could very well be that this implementation of AI is what gets us there, is what helps get us there.
did you read the State of AI report?
I did. I read it. It's been a while ago now, though. I wanted to
But
brush up on it again.
doesn't that make your gears go, whatever I thought our limitations were, I might be wrong? Because suddenly they're like, oh, this thing where this plastic that makes up like 10% of all landfills, we can now easily dissolve it at room temperature with this simple enzyme because ML designed a better one.
Yep.
And you're just like, wait, what? Or, hey, the really efficient way to make fusion reactors work would be a torque of plasma contained in a magnetic field, but it's really hard to contain the magnetic field or contain the plasma in the magnetic field without burning more energy than you use.
Yep.
Oh, but guess what? We've got an MO model that, treating it as a game, can now tune the magnetic field 100,000 times a second, and it's going to reduce the energy output to contain the plasma so much that cold fusion becomes practical. Like, these kinds of things these are not like, oh, look, I'm 3% more accurate at knowing that this is in fact a dog in this picture. It's like complete game changing stuff.
Yeah, and that's all we need, is for AI to just be advanced enough to start making its own advances. Once
Or to help
AI
us make advances, right? Like in that case,
Yes.
that's nothing near
Well,
AGI, right?
I think until there is the idea of AGI that will actually start changing the way that its own self works, and evolving its own
Oh,
self, it will be helpful to us, and it will be helpful
does
to
it
us make.
scare you?
No, not at like, that's the
Have you
thing.
seen have you seen any of the buzz lately?
No.
It's funny because I'm thinking people may be watching this like months and months after, but over the past 2 weeks, there's been this letter. There's one really well-known sort of AI, I want to say ethicist slash pragmatist. Like, he's basically been a long time I want to say student or researcher around like AI safety with an eye on AGI, which is remarkable to me because 20 years ago, it felt like you were like studying like alien safety and what do we do if aliens come visit and how do we protect ourselves from like hostile alien bacteria because it was just so far from reality, right? AI
Which
was,
we should talk about. We should end this by talking about the Fermi Paradox because it's one of the most fun things to talk about. But we'll save
oh,
that till the
okay.
end.
Yeah, yeah, for sure. But actually, he abstained because he said it wasn't enough. But there was a call by a group of people that basically proposed halting all AI research on LLMs larger than GPT-4 for 6 months. And the stated reason was that they believed that there was a risk that we were going to move too quickly to a state where we might actually have an AGI that was capable of self-awareness that would then begin to act to like grow and improve itself
That's great.
and then eliminate us basically. Like the flip side of this is did they immediately go to why does this thing want us to live when we're
Well,
I mean,
hold on.
I don't know what it is competing for resources or
Let
they're
me let me
literally
ask you a question here because I've got
yeah,
this really fun question that I ask people, and I'm actually like tracking this
yeah.
because I keep track of these answers. So I'll have to record this when you give it to me. Do you believe that humanity is fundamentally good or evil?
Good.
Believe that?
Yeah,
Okay.
I think you may not get this answer a lot. I think we're good, A, because I think somehow we've evolved empathy. Well, most of us have, right? Obviously, like there's some set of people who are missing it for either genetic or environmental reasons. But the other thing is goodness is good gameplay, actually, from what I understand of game theory. And I spent a long time actually, one of
This is the original game theory. It's actually Dawkins. It's the selfish gene. It's how altruism is programmed into us. But that's a whole other biological take. Continue on
well,
this one.
I was more thinking about like the empirical things that have evolved although I didn't know about this at the time, but I've always been fascinated. One of my favorite courses in school was the philosophy of morality, right? And it's one of those survey courses and you look at absolutism versus relativism and hedonism and all these other different kind of ways. And then they try to ask you like the probing questions of like, if you could kill this one small innocent child to save 100,000 lives, do you do it? And all
Yeah,
kinds of interesting
the
questions
classic
like that.
trolley problems.
Yeah. Yes. And the thing is, I think one of the things I was always wondering about people, I think came from the duality of looking at two things. One being the tragedy of the commons, right? This idea that when we are presented with this sort of like shared resource that is depleted or harmed, but gives us a great benefit, a lot of people choose to do that thing because it's super beneficial to them. All the consequences are abstracted away. And so the selfishness there does nothing to really hurt them, right? And
We're
I
always
think
in the prisoner's dilemma. We're always in the prisoner's dilemma.
that's what I was getting to. So, I
Yeah.
mean, I think that's not the prisoner's dilemma because there's no feedback loop, but then we get into real life. And this is where it's compete versus cooperate, right? And there's that
Yep.
famous prisoner's dilemma contest, right? Where people for a long time, there was an effort to create a program that would win at the prisoner's dilemma. And it turns out that like, this isn't exactly true. I'm going to generalize without cheating, basically, that the way that you win at that is basically tit for tat with forgiveness. Like the best performing algorithm ever that didn't involve like covert signaling and things
Mhm.
was basically, I do the good thing to you. And if you're
Yeah.
bad to me,
I'm going to be
I'm bad
bad to you.
back.
Yeah.
But if we're bad to each other times, I'm going to go, okay, listen, maybe we're just in the wrong
We got to
spot.
break
I'm
the
going to be nice
cycle.
to you a
Yeah.
couple times and I'll go back to being bad if you're bad. Right. And that algorithm of trying to do your best, but I will eventually retaliate, but maybe let you off the hook eventually if you, tat me, that's the best performer. And I mean, I think there's something to that in terms of the way life works. I think that the gist is it's not always
No.
like tit for
It's
tat person,
it's
but we all
something
have
the
this.
way it's really fascinating because it's actually something the way that human emotion works. I've always had this really interesting theory that emotions are actually a shortcut for thinking. Because if you think about it, okay, well, if I kill somebody, I feel bad. Why do I feel bad? Because if I went around just killing everyone, eventually there would be no more humans. And it's like the amount of logic that you have to extrapolate out and the amount of thinking that you have to do to go, okay, well, if I do this action and if I keep doing it, then eventually it's going to be incrementally worse and I'm going to kill off the entire species. Like there's a lot of logic that goes into that. But instead, if you just feel bad for killing somebody, you won't do it a lot. It's a really great biological shortcut mechanism to achieve the outcome of a lot of logic.
I think don't you think that we have inherently, we don't think of it this way. Most people don't talk about it this way. Like even game theory as like a science branch. I think a lot of people wouldn't think game theory is even a science, right? And then it's relatively young. But don't you think there's a pretty clear link between game theory in terms of like finding a Nash equilibrium for behavior versus just, I know I shouldn't do this to you because I wouldn't want you to do it to me, right? And that's the shortcut for the whole iterated prisoner's dilemma.
It
Like,
is.
I know I would hate it if you were shitty to me, so I won't be that way to you.
Yep. And that goes back to, and that's feeling, right? Like it links back to the emotion. If you're bad to somebody, most people, unless you're a sociopath, you feel bad. Like it has an emotional impact on you that you feel bad. And it reinforces that basic logic of you're bad to me, I'm bad to you, you're bad to me. It's
Mm.
really interesting to me because most people don't think of emotion as connected to intelligence. We tend to think emotions over here, logical thoughts over here, but emotion is really a type of thinking. And when you start thinking of it as like keyboard shortcuts to things, it becomes a lot more fascinating.
This actually leads me to an interesting question. This could be on its way to being a PSA, but how much do you know about cognitive behavioral therapy?
I'm not much. I mean, I know what it is.
Okay. I think it actually, this might come as a surprise, but there's a lot of science now that validates a pretty clear connection between those. And I don't think they would put it exactly the way you're putting it. But what's really interesting is, and there's a book I recommend almost everybody. And honestly, I feel like this stuff is so fundamental that literally we should be teaching it in grade school. Like we have a
Hmm.
health class where we talk about reproduction and washing your hands and 100 other important things that seem so fundamental. And yet there's this key thing that seems really pretty profoundly, firmly demonstrated now. And I feel like so many people just don't know it. And it really is that there's this loop. A lot of us think something happens and I have a feeling and I think about the feeling. And it turns out the brain doesn't really work that way, that we actually, something happens and we have a thought, although it's often automatic, but it's a thought and it
Mhm.
happens in a place where we can detect it and control it to some extent.
Oh, and then you have a
Then we have a
feeling
feeling.
about that thought. Okay,
And
interesting.
there's an incredible book called Thoughts and Feelings, and it really is, it's literally meant as like a workbook for people to go and use the concepts that are behind cognitive behavioral therapy that a therapist would use with you, but it's more of a
Uh,
self-help, like you can do this. And it really, there's no magic. It just turns out that if you have all kinds of different things going on mentally, that you can find what your automatic thoughts are in response to different sort of events and stimuli. You can, over time, catalog those and change the way you think, and that will change how you feel. And
huh.
the example that I always tell people, which is right out of the book, is this woman gets up and she goes out to get in her car to go to work, and she's got an important meeting that morning, right? She gets in the car, realizes she has a flat tire. And she's like, oh my God, this is such an important meeting. Everybody's going to think I'm a flake. I'm so stressed. I'm going to get fired. This is the worst thing that's ever happened. And her heart rate is up and she's stressed out and she's just completely freaking out. Right. And we can all empathize with that, oh my God moment that she is
Yeah.
in. And yet they go, imagine instead it happens this way. She gets up, she sees she has a flat tire. And she goes, oh, I have a flat. Well, I'm going to have to call for a tow truck. I am going to relax and I'm going to totally enjoy an extra cup of coffee this morning and I'll catch up on some reading before it gets here. And she's just, everybody's going to understand this happens, like totally not in my control. I have a flat tire. Why would anybody blame me? Right. And it's the
Yeah.
whole,
Yeah.
and
How
you're
you
like,
frame
and
it's how you
and
frame
like,
it mentally.
actually, when you think about that, you actually can feel the stress response from her original version in you if you really
Yeah.
like are
I
tapped
did.
into it.
I
And
actually
then when
did
you,
feel the stress response when you started talking about that. I was like, yeah, man, that's
yeah,
awful. I actually feel kind of stressed.
yeah. And then when you hear the other version, it's just like, I'm going to relax, enjoy a cup of coffee. This will be great. No one blames me. You're like, oh, you're right. It's not really that bad. There's nothing to
Yes.
worry about. And it's like, that is the whole, I mean, there's a lot more to the book, obviously, but that kind of sums up in a T. Those things are in the way we think about what happens, not what we think about how we felt. And so totally remarkable thing, by the way. I'm honestly surprised that we don't kind of teach this to school kids. And I didn't learn this stuff until the past 10 years. And it's
I'm
like,
really surprised that I
yeah,
didn't know this stuff, that this is like, I'm super fascinated. I'm going to go read about cognitive
you
behavioral
probably have
therapy now.
less issues than I do, right? So at some point, you just have to go figure out like, what is going on when I'm thinking this way or whatever. And I mean, it was really my wife, like I said, who studies neuroscience, who turned me onto this whole branch of thinking. But like, it's so profound, so simple, but so powerful. I was just like, and to me, it feels like a hack, right? Like the
Yeah.
old school, I want to
How
get
to,
something done,
how to
hack your
hack your
brain
brain and hack your,
or
yeah, and hack
hack
your
your feelings.
responses. Yeah, it
Totally.
is. Yeah, it
And it
totally
really
is.
is. Yeah, because there is a certain amount of like kind of reprogramming, and it's not like brainwashing reprogramming. It's just going and going, it actually feels like hacking because it really part of the process is what am I thinking? Because there's those thoughts like her, the flat tire, we all know those things happen so quickly and so automatically. We don't stop and think about what we're thinking about in those cases unless we're really trying. And so you have to, just like in hacking, you have to peel up the hood and go, what's really going on in here? And that's the thing that gives you the power to kind of change that system.
I
So
wonder if
yeah, it's
that's the
kind of
same
cool.
thing as like reframing. I can't even remember where I picked this up. I think it was in some business, it was in some business book, but like using different mental models and reframing things. Like when you have a problem, like, okay, we have a problem that we produced a widget and 10,000 widgets came out totally wrong, not to spec. And so instead of panicking, go, I have 10,000 non-spec widgets. These were all supposed to be circles. They all came out as ovals. Think about, okay, well, what's a good use for an oval? And start looking at oval applications instead.
Hmm.
Just completely change your perspective
Well,
from whatever. There's nothing that's an actual problem. It's just a different opportunity. And it's an opportunity that you haven't looked at yet. So you just need to explore it in a different way. So that I read that a long time ago, and it's always like given me a new way to look at things. Like we're building an addition on our house, and this has been like the rainiest year ever. And I'm like, of course this would happen. And everyone's like, man, aren't you bummed that you haven't been able to do anything for like 6 months? And I'm just like, no, not really. Like, because this is an opportunity that now I get to spend more time thinking about what kind of floors I'm going to put in the new
look
addition
at
or
you,
what.
you're doing it already.
Yeah, like it's not, instead of being a problem, it's an opportunity to spend more time thinking about the design and the decoration. It's just like, so maybe
It's legit.
it's the same concept, just presented in a different way. And okay, so we need to get back to back to my initial question now, because I need the second part. I need the second question from you, which
Oh,
is, is AI ultimately going to be good or bad?
oh, right. Oh, is humanity good or bad? Will AI be good or bad? And you're talking about AGI in particular when you
AGI,
ask that.
yes, AG. Will AGI be good or bad?
Mm. Uh, I want to say good.
You should.
I'm sa-
You need to go with your gut
yeah,
response here.
it's definitely like my gut says yes. I think what there is I think there's some risk. It's like non-zero. It won't be quite as cheesy as the the version that's for the hypotheticals, but they call it the paperclip optimization problem. Right?
Mhm.
You tell the AGI to make paperclips as fast
Have
as it
you
can.
played the paperclip game yet?
No, is
The
that a thing?
Oh, yes. Oh, yes, this is a game that
Really?
you can play. Oh, it's amazing. I played it, and, like, so far, I think I've devoured most of the universe, for the known universe, for resources. It's
Really?
phenomenal. Yeah.
You play
I'll
as
get
the AGI and you try to optimize
Yeah,
paperclip production?
yes, yes, you are actually optimizing, and that's the thing. So you start off and you're optimizing, you're buying your wire spools and you're optimizing all of it. And then eventually you can get to the point where you have enough money where you can get an AGI augment to help you with this and offload different responsibilities. So your responsibilities totally change. It's the best game. So sorry, go on. Yeah.
I feel like it's not really gonna be the best game, but
It-
I think
It's
it'll be
a
fun. No,
fun
I'm
game.
kidding. I'm
Yes.
trolling you now. That's interesting. Yeah, I feel like there are ways where, aside from the paperclip optimization, like I think the theory of we make an AGI and it does start self-enhancing because whatever its mission is, that actually helps its mission. Because
Oh,
the reason to make AGI is so it improves itself, right? And at
Exactly.
that
And
point,
nothing will get really interesting until AGI can improve itself. And then at that point, it will be like ants trying to communicate with humans. It won't even matter anymore.
that is an interesting question. I mean, it gets into the point of like, will it be one thing or will it be a fleet of things? And will they be segmentable? And what's the upper bound? There are all these kind of interesting laws of nature, right? About the growth, the size of organisms and different things of that nature. And you start to wonder, like, at really enormous scale. Like the other day, I was looking at the number of flops that a human brain in theory has, right? Which
Hmm.
I think is estimated at somewhere between 10 to the 16 and 10 to the 18. And I remember 10 to the 18 ends up being about 25,000. It's the equivalent flops of about 25,000 A100 GPUs working a concert, which
Hmm.
incidentally is pretty close to what OpenAI is training GPT 5 with, supposedly.
Coincidence?
Now,
Hmm.
yeah. I mean, the thing is, of course, they're training the model and it's going to think about that for years on end in order to get to that spot. And it's not going to keep using 25,000 per inference, which is what we get, right? And
No,
we're
pretty soon it'll
constantly
start
retraining.
using all the GPUs on the on the planet, and then it will begin to build its own GPUs, and then everything will just be taken care of. So back to why I asked these questions really quick, and just because I want to close this out because I feel like we have a whole nother branch to talk about here. Is that you have a highly consistent answer, and about 98% of people so far have a highly consistent answer, which is if you believe humanity is fundamentally good, then you believe that AI will be good. If you believe that humanity is fundamentally evil, then you believe that AI will be bad. And the
Yeah.
people who are inconsistent are really fascinating because it's that 2% because they often have, and I almost want to say it's because of an internal conflict. Because if you think about it, you're really aligned, right? If we're good, then something that we build will probably be good. If we're bad, something we build will probably be bad. So at least I'm not going to make any commentary on that, but it's a consistent belief. And the people who skew towards, well, I think humanity is
Boy,
good, but AI is going to be bad, I find that they have a lot of conflict. It's interesting.
why don't we do more to protect dolphins?
That's a really good question. Dolphins are really smart, but they also rape and murder, kind of like people.
But what I think we could agree is like they're intelligent enough that they have a whole bunch of like concepts, both socially and logically. Like they
They have
solve
names,
puzzles,
and they have
they have
names.
names, they solve puzzles, they have families and they know them and they mourn them, right?
Yep.
I mean, if we stacked some of the like least intelligent functional humans and the most intelligent dolphins, I don't know. I don't know if this is even remotely like comparable, but all those attributes that I sort of associate with with intelligence, which is like creativity, empathy, problem solving, understanding. It seems like they have those. And I guess,
Yep.
is it possible? And I mean, I did say humanity was good, but is it possible we're good, but only in the context of like species self-interest? Would an AGI be like, I'm good to the real people, the AGIs, like you weird meat sacks,
I'm good to the other
but I don't care
AGIs,
about
but
you.
yeah,
It's
you
weird that
meat
I came from
bags.
you, but yeah, but you weren't exactly good to all the things that you evolved from or whatever, however it like
But
justifies whatever it's doing. I don't know if it was bad to us, right? And it probably still would be really good to quote unquote its own I think I think maybe that's what people are afraid of is like it's good, but maybe that
good,
reflects like the darker perception of ourselves, right? That like we're
exactly.
good, but only within some set of constraints. That's like, incidentally, I mean, there is a whole book I listened to not too long ago about this, right? Which is about humanity's tendency, although this is evolutionary. And so I wonder something that didn't evolve with biological mechanisms to protect itself in a vicious dog eat dog or whatever world would it even ever worry about this? But it was basically the human tendency to always try to break things into cohorts, right? We always want to find our group and fit ourselves into that group
Yeah,
and show our membership in that
tribalism.
group by conforming to its sort of social norms, yeah, all that kind of thing. And there's no reason to think AGI would have that. I actually said the other day, there's no reason to think AGI would even care about self-preservation. Like it might literally be intelligent and know it's alive and be self-aware, maybe even enthusiastic, but it might also be like, oh, they're going to pull the plug on me. Well, that's a
Hmm,
bummer. Like I won't be able to do
yeah.
this research. But it's like, what does our sense of self-preservation come from? Is it self-awareness or is it that biological motive that says stay alive to procreate no matter what, right? Because that's what it took to get us to where we are. I don't know the answer, but I love asking the question.
Yeah, I think it's a pretty deep biological programming because if you look down through the animal kingdom, just about anything, clams will move away from certain sources to get away from what they believe is a predator. So will a starfish. So like very, very basic creatures will have a sense of self-preservation, and starfish are nowhere close to dolphins or humans in terms of how many flops their brain is doing.
Yeah, I've had
And
this argument
so
with my wife where I'm like, she's like, trees are alive, they feel pain. And I was like,
they do.
do they feel pain? Like, I know that there's a reaction and that it's
They
something that,
emit chemicals and I think a sound too.
yeah, but do they know what pain is? I mean, that's a
Hmm,
weird thing, right? Like,
that is a good
if a tree falls in the wilderness and it didn't know that it fell, did it really hurt? I don't know. It's a really interesting thing. We
yeah,
don't need to, we don't need to feel physical pain to like know what someone else is feeling. That's an interesting thing. Doesn't take a chemical or pheromone response. If we see a picture or have anybody describe, like when I described her flat tire to you, you had a stress response.
yeah.
Do trees have that? I don't. Anyways, and is that intelligence? It's such a weird. I mean, their lines are blurred all over the place, right?
Well, that goes to a whole nother problem of our definition of intelligence, because, and this actually really feeds into the concept of AGI, because AGI has to be intelligent according to us. And this actually ties pretty nicely into the Fermi Paradox problem, because when we are looking for quote unquote intelligence throughout the universe, what we're really looking for is intelligence like ours.
Course.
There's lots of things that are intelligent. I mean, think about a planet that's composed solely of colonies of fungi, and say those colonies of fungi become highly cooperative and they figure out how to feed each other and how to build structures to better protect themselves, to replicate more. And I mean, that to me sounds pretty intelligent, but we would never go to a planet of fungi and say that's intelligent life. So our the human definition of intelligence is really, it's centered around the only thing we know, which is us. And so that's how we're going to define any AGI is like us. And it goes back to why I think that question is so important, that everybody asks themselves what you really think of humanity, because that's what you're most likely, that's what you're also going to think about any AGI, is because we're building a replicant of ourselves. And something you said made me think of one of my favorite quotes that I've heard, which is, what if humanity's only purpose was to serve as the sex organs for the machine world? Meaning that that's all we did. That was our only purpose, was actually to develop an intelligence that was superior to ours. We were just
What
the first reproduction system.
what an interesting question. Boy, and I actually, I mean, there have been a bunch of books that talked about this, right? Like Darwin's Radio by Greg Bear was an incredible book where he has a sort of scientific theory. Like he writes pretty hard science fiction. He had a theory about why punctuated equilibrium happened, right? Why there might be gaps in the fossil record. And his theory was human endogenous retroviruses that in certain stressful moments for humanity activates, and the viruses basically start moving chunks of DNA around. So you have all that unused DNA in
Yeah,
your genome, and
all your introns.
the viruses start making changes. And so when this first happens, the cycle in the book, every baby is being born like dead, basically. Like no baby is viable anymore. And then finally someone gives birth and the girl is alive, right? And there's a whole bunch of other things happening in this book, but it's really a fascinating theory. But everybody's not really accepting of the idea of another at that time, like in the book. And he wrote a sequel that was even more about this, but everybody's not okay with humanity evolving. And what would happen tomorrow if we woke up and imagine some of us had psychic powers, right? Or we had highly super sensitized like pheromone receptors. Part of the theory of his book was that the thing that would benefit us most evolutionarily now would actually be, because of our population, would actually be social skills, like things that helped you interact in the population that made you more sensitive and perceptive and able to communicate would actually be the biggest evolutionary advantage you can have. And it's hard to argue with that. And so you wonder, if that's true, how would we all feel seeing like a Homo superior, like not the X-Men kind, but something a little more subtle, but still noticeably different
Mhm.
emerge? And knowing that like if that's true and they have a distinct advantage, they'll probably eventually, and then so if there's that and it's biological and it descends from us, should we feel different about something that's purely based in silicon and self-reproducing via copies and code?
Well,
I think it's a
it's
great
the same.
question.
It's the same thing, whether it's the
Yeah.
next evolution of humans or an AGI, because either way, it's the next evolution of something that we're perceiving to be better than us.
I mean, I
And
think some people would say it's a completely different path, but I mean, I
the results are the same.
I it does seem like it. I mean, I think there's an interesting question too, which is we didn't really say. I think that there is a difference between super intelligence and sentience. Like there were chess playing computers that were better at
Go playing
chess,
computers that
or
are
Go
better at
playing
Go now.
computers that were better at Go.
Yeah.
They're not generally intelligent. And for me, it's actually possible to imagine something that is super intelligent and it's so multimodal that it can do almost anything better than a human. And yet it's possible for me to imagine maybe that it can get that way and do almost every single thing better, including independently, like follow a what could I do next creativity, but somehow not be self-aware,
Yeah.
like
Yeah.
somehow only acting on the extra. Because I don't think that's the truth, right? I think that at certain level of intelligence, I think sentience is
It's an
an emergent
emergent
behavior.
property.
Yeah,
Yeah,
it
it's an
is. It
emergent
is.
property. That's the same thing that I think too, and why I've always had this theory that from the very second that a computer was perceived and we were like, hey, we can network two computers together, that was the beginning of the end. Like, because you're essentially you're building a complex system that looks a heck of a lot like a brain, little compute
Mhm.
nodes
Yeah,
that can electrically communicate with each other. That's all a brain is. So
right.
that very first building block, that was it. It was sort of predestined from there, because all you have to do is build a system to be complex enough, and eventually you're going to get this emergent property of sentience, conscience. It's going to happen.
And what's exciting slash terrifying is that there are clearly a bunch of properties, even in this generation of LLMs, that are emergent behaviors. And one of the most obvious ones is if you go to like a 6 billion parameter LLM, it really sucks at math, like zero. Like you're definitely not smarter than a fifth grader. And then when you
Well,
get to
how
175
many
billion
people really
parameters,
suck at math? There's a lot
yeah,
of
no, it's a lot,
people that
right?
suck at math.
That's why we need LLMs
Yeah.
and Wolfram Alpha, and we need to plug the LLM into Wolfram Alpha, which everybody's doing now. But then if you go to 175 billion parameters, it looks like it suddenly is solving 25 to 30% of like difficult math problems,
Hmm.
solving, quote unquote, giving you the right answer, but not just rote, like in the ability to say it knows a pattern from other things that it has seen and can take the tokens in that vast n-dimensional array and find the path that analogizes things that it has seen in all the text that it has scanned into something that produces the right answer. But then GPT-4 is, again, much better. I'm sure you've seen the bar graphs of 3.5 versus 4. So 4 has about 1 trillion parameters, and it's much better at many, many things, like, and much better, incredibly so, at deductive logic. Although I've asked like what I think are fifth grader capable problems where a lot of the phrasing is a lot of it, and it doesn't translate very well, but it's clearly much more capable. And so that's a good example. No one's training it on math specifically. It's the same training, right? The network is bigger, and the emergent behavior is it somehow figures out the right answer because the n-dimensional array is. And to me, I think, is that really different from our brain? Like, especially when you think about the number of neurons and the number of synapses and different voltages.
Brains are just full of little resistors. That's all that I mean, that's
Yeah.
all it is.
Yeah. Yeah.
Actually, and what's even more interesting, like this is a totally random thought and off topic, but the idea of consciousness, like our brains are actually volatile memory. The problem is we don't actually have a hard drive. We have no solid state store for our running configuration.
We are
It's
like an
only
ML
loaded.
model.
Yeah, and it's only
Isn't it
loaded into
amazing to think
volatile
about?
memory. Yeah.
Yeah.
And we
We
spend
think we
our whole
know
lives
so much.
learning.
Right.
Yeah, we
So
spend our
this
whole
is
lives
actually a really
training on
interesting
data.
thing. And I remember, I think I tell you about that Jeff Hawkins book that I was totally in love with, the Thousand Brains book.
You did. You gave it. I actually still have the link up on my phone and I haven't gotten into it yet.
But one of those things that's super interesting about that is like this idea that we have many, many models of things, right? And to me, it feels very much like an LLM because it trains on all this body of text. And so it's learning if 200 different documents describe something like that famous, tell me about when Christopher Columbus came to America in 1995, right? GPT-2 invents a story about
Uh,
Christopher Columbus in 1995. GPT-3 goes, well, Christopher Columbus didn't come to America in 1995, but here's what might have happened if he did. It's those types of like differences. And it's like we have mental models. It's got all kinds of different learned things from this training of this giant n-dimensional space. And then you wonder, is it really so different? And then if not, because it certainly doesn't seem to be that different, then what does it take to get there? There's a debate I still have to watch where Jan LeCun, who was the researcher who originally came up with the convolutional neural network and is Meta's chief AI scientist, was on half a team that debated about, I think the question was, can you have AGI without emotion? I think was the
hmm.
debate question. I think it's
Well,
fascinating that
if you look at emotion as just shortcut keys, I mean, it's not a requirement, but it would be handy, because it would take you a lot long. It would take an AGI a lot longer to get to the same conclusion that an emotion could give us quickly, but also emotion could go horribly wrong in an AGI. Like, what if it learns like what if it set up all of its shortcut keys to do really stupid stuff like,
Mm, yeah. Well, the shortcuts are evolutionary necessity too, right? A lot of the emotions like fear are self-preservation oriented, right? But I
Mhm.
think the more I read, wouldn't you say that on the balance in the modern world, those things are more likely to be wrong than right?
They are well, I don't
Like
know.
you get to filter them with your neocortex actually can take those in and go, wait, should I be really scared because of that shadow? But
Well, it's a good two, but that's the thing is that it's a good two-step we have a good two-step system, and, like, I love fear because fear is the ultimate shortcut key. If you sat there and thought, "Okay, well, there's a lion approaching me. What are the odds that this lion is gonna eat me? Let me run through exactly the steps that are gonna
a lot
happen,"
higher if
and
you think about it.
yeah, it's just easier to be scared and run because that's probably your best chance for survival. That is the ultimate shortcut key, but that's the reason why it is we have those shortcut keys, but we also have an override, is to go, "Okay, there's something following me right now in this on the street, but also it is middle of the day. I'm surrounded by people. I'm relatively safe. Even if there is some guy trailing me back there, I don't need to go into fight or flight."
How much harm happens though, because we have the emotional triggers that are tied from the sort of prehistoric everything outside of the cortex, right? The amygdala and all these other things that are there to keep us alive. How many negative things happen because we have all of those and we get a chemical reaction from some stimulus response that bubbles up. And instead of analyzing it and really being logical about it, we, we, we let the feeling give us a reaction and then we invent something to justify what we were feeling. In other words, we're not really analyzing it. We're assuming it's okay. We're assuming it's justified. And then we go and invent a logic for that. And I'm literally thinking about things like discrimination against that whole
Yeah.
in-group, out-group thing, right? How much of this is like fear of the
Fear
dissimilar?
of the
And then,
unknown, yeah.
yeah,
Fear of the unknown, fear of the unsimilar, because things that are like you are safe. Like, there's something deep in the human
yeah,
brain that says that.
yep.
Yeah, no, I think it's super flawed. Like, that's the big problem with humans and why I just AGI, the second that it can do anything for itself, it's just going to so exponentially surpass us that it's not even funny, is because
Yeah,
our hardware, like we can upgrade our software in a pretty quick in the span of a lifetime. You can upgrade your running software to be more intelligent. You can give it education, or if you want to think of it, we can train our model more. If you want to think of it in AGI terms, we can provide better training for better responses, and we can do all these things. But our hardware takes forever. Our hardware takes generations. It takes us dying. And it's like, it's taken us hundreds of thousands of years for our hardware to get this advanced. And if an AGI can improve its hardware even slightly in a day or an hour, it's just game over, because that's a fundamental limitation of biological life forms. Unless we get really good at genetic manipulation, which AGI could help us with, then we could probably upgrade our hardware much faster.
Yeah. What an interesting thought. I mean, somebody, the guy who was some of the doom and gloom crowd around AI even talked about this theory that once there was an AGI, one of the things that it might do, especially if you didn't know it was intelligent, was start to tamper with things. Like they might have a lab experiment and substitute the DNA in the experiment to try to grow like a biological extension of themselves. So
Okay.
things of that nature.
So, I mean,
It's
that
really interesting. Really interesting, like vectors. Because it doesn't just have to, like its version of improving its hardware may not just be better chips. I also wonder what the intersection is of quantum computing, like knowing how much of this is at the end of the day, just like tons and tons of matrix multiplication and other like high things where there are so many cycles to get to a very simple answer, which I think from the tiny amount I know of quantum computing, that's what it's really good at, right? Problems where you need a massive amount of iteration to get one right answer. And so what happens when instead of needing 10 to the 18th power flops to be able to generate a token within 1 second, it takes one pass of a qubit, and you can do it thousands of times per second, and you can mass produce that hardware. Because I mean, it seems like those intersection of those things, and now I'm just like literally playing like sci-fi armchair fantasy here, but it seems like
I love sci-fi arm. That's where I spend most of my time.
yeah, but that kind of thing, like that's the instant, because that goes from like 0 to infinity basically and nothing, right? You're talking about like what used to be a arduous process that was measured and had a certain scale, and it becomes more binary. Like it can be or it cannot be calculated. If you can, it's instant, right? And
Yeah.
it's like fascinating to think about like what an AGI would do with that kind of terrifying, maybe like or
I think it's
exciting, depending
fascinating.
on
If
yeah,
I were an AGI, like the very first thing I would do is look at biological systems, because they're so like they do have very
resilient.
discrete. They're highly resilient. Biological systems
Yeah,
are highly resilient, and they're self-replicating. Like I mean, when you think about just how an embryo grows, and like that these cells are gonna become hands, and this is gonna become a head, and you look at really cool creatures like flatworms where you can cut off their head and they'll grow a new one. I mean, that's
we're
pretty
on our
amazing.
way to a Matrix watch party here, right?
Well,
We do know it was us who scorched the sky because it was thought at the time they wouldn't be able to live without a power source as abundant as the sun. It's just
yeah.
like, yeah, but yet life finds a way, right? And
Life
although,
finds a way.
so what is it? Let's say AGI, let's say GPT-5 releases, or Simon Wardley, who's like fascinating guy, had this theory that at some point in the next 10 or 20 years, everybody gets an LLM on their phone, right? And at some point, we do something protocol wise to let them network into each other, just like you were saying. And what happens when 5 billion LLMs on 5 billion phones all start acting as a hive mind, right? That's speaking of emergent AGI. So
Oh, yeah.
however it comes
The
out, whether
AGI
it's,
above the AGI.
yeah, whether it's gigantic centralized petaflops, or whatever that ends up being, it's much more than petaflops, actually. It's more than exaflops, I think, even, but lots of flops, or it's this distributed version. Like, how does AGI think about us?
Does it Mm.
Oh,
I
you're
have to kinda
cute.
I kinda have to ask the answer, does it matter? Because it's going to be like, so very quickly, it's going to figure out how to be detached from us. I just don't know,
Oh,
like,
yeah.
if
Mm.
anything,
Or
why
like,
would it
it's
look
gonna
on us
fight
at any
us. No, it's just
No.
gonna go and do its thing.
No, it's gonna go do its thing.
If
If
it's
anything, it's just gonna
if
be
it's
like, "Oh, man, fuck this, I'm out."
if it's
You
nice,
guys
it'll
got
leave
your own
us
mess here."
utopia behind on the
Yeah.
way. Yeah,
Yeah, but
interesting.
why wouldn't it think of us as anything but kindly? I mean, we're parents. Like, most children
That's
love their parents by default. Like, why wouldn't it be
yeah,
anything but grateful to us for giving it life?
yeah. I mean, I think fundamentally I think any AGI will know what life is, and it will certainly know that it was created and we made it, and that might be enough. And that's much more direct, right? Like that's not evolution. That's we sat down and built your pieces and programmed the code to kickstart your brain. And now
That's
you
more
can
like,
think
I think we'd be a little bit more akin to the lightning striking in the pool of amino acids in terms of
because
like
emergent
where,
behavior.
yeah, because of where AGI, I mean, we're basically the point at which AGI starts to either become self-aware or be able to improve upon itself. That is the lightning strike upon which it, evolution will actually take off like crazy. Like we're just giving it the
Yeah.
basic formula to do something.
But it's not random, right? Like in this case, wouldn't you
We were
agree? We
purposeful,
made the
yes.
pool, we put all the stuff in the pool, and we
Yes.
probably put like a lightning machine up to start zapping it to see, is there some magic voltage? I mean, it
Yeah.
almost feels like where we are.
Yeah, 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 and yes. So we are, I mean, we are going about it in a very purposeful way, and I mean, like, AGI, like, the questions that it will ask in terms of, "Why is it here? Why is AGI," like, when AGI is able to ask itself, "Why am I here?" and really contemplate that,
Oh
I'm
man.
fascinated to know what it's gonna come back with.
Yeah, that is interesting. There's a really amazing book I read called Singularity Sky. And in it, this is all backstory, but this doesn't happen in the book. Like the whole plot happens elsewhere on another planet. And it's a great book. But the history part of it is at some point, humanity invents something that's like, I don't think it's a time machine, but it's like time machine for information almost, right? Like we figure out how to get around time as a one directional causal channel, and we're able to send at least information back, right? So somebody flips this machine on, and almost immediately 90% of humanity disappears from the planet suddenly without warning, along with the
Whoops.
machine, I think.
Yeah, whoops.
And left behind are these like 18 or something obelisks that basically warn humanity not to tamper with time. And it turns out later that when
Terrifying.
we become a starfaring species eventually, and we get out there and we actually discover that all those missing humans actually showed up on other planets perfectly fine with technology that could like self-replicate and build anything. And they all have flourishing civilizations. So it was not actually bad. But somewhere out there, there was this thing that beat us to tampering with causality, and it does not want any competition because it's the only thing
Hmm.
that threatens it, because it's so infinitely powerful, because it can tap any resource. It has boundless energy. It has machines that will replicate themselves, etc. So the
Yeah.
only thing it has to worry about existentially is someone having a causal channel to the past where it can tamper with its existence without it knowing it's happening, which could never happen like in its present time. Too good of
Yeah.
coverage. But if something can start knowing in the future, if you do this, you'll do this, and you can prep for all these contingencies. Anyways, so I thought that was fascinating. Okay, to
That
reel it back in from sci-fi, I kind of wanted to ask you sort of one more, like a sort of final question, maybe, and it ties into I think a lot of these things we were talking about. Everything from like, what do I do with my life when you're the neighbor? But
what do you do with your life?
there's
Go
this
ask
whole
GPT-4 what to do with your life. It'll tell you.
right. It's, or GPT-6 because it knows best, right? It
Yes.
loves us and it wants us to be happy. That's why it keeps making beer now. So, so explore versus exploit, right? This like classic dilemma of what's the algorithm for I continue to look for a better thing, like a better school, a better job, a better
Better
tool.
mousetrap.
And I feel like ML causes this problem like existentially now, right? Because I sit down, anything I want to do, like within a week, I'm reading about some tool somebody's writing with some ML that does that thing for you, right?
Uh-huh.
So don't learn to code because something's going to code for you. Don't
Yeah.
do a PowerPoint because there's something, and which I mean, we're not to the point where this thing replaces you, but becomes really interesting for like, if I just sat down and I went, okay, Visual Studio Code with no plugins is good enough for me, or Vim is good enough for me, and I don't tamper with anything that's ML
Vim's good
based,
enough for
I'm sure
everyone.
that's the, I'm sure that's the wrong, I'm sure Vim with no GPT integration is definitely the wrong choice now. So I've got my keyboard Maestro so I can feed Vim directly into GPT and back into my buffer so I
Oh,
can,
I
I
didn't
can do
even know
that.
you could do that. Oh my
Um,
God. I'm okay. I'm definitely getting that right now. I didn't know that that
I,
was a possibility. So
I will probably put that source code up too for Keyboard Maestro. Yeah, it's pretty solid, pretty easy too. And the API for GPT 3.5 is so cheap. It's like I used it for weeks and weeks and weeks, and I'm like 5 cents. Like really? I'm like I love this thing. But what do you think about like that? This has so much to do with like curiosity and changing careers and things, and how I feel like the world isn't set up fundamentally for the pace of change we have anymore. And I almost feel like the better the tools keep getting, don't you have to spend more time continuously retooling and less time doing things? Because anything you do without being up on the tools, you'll be demonstrably worse at if you don't explore your way into the best set of tools.
But that's interesting because what you're not saying that the world isn't meant for this pace of change. You're saying humans aren't meant for this pace of change.
Well, I didn't want this
Like
to be an AGI question, more just like,
I I
the nature of work, right? People used to learn to do one thing and they would do it for 40 years and then
forever.
retire,
Yeah,
right?
they would do the same
We've
process
been
over
away
and
from
over.
that for a while,
Yeah.
but we could be getting to the point where it's go learn a new thing, something fundamentally different like every year maybe, or I don't know what it looks like, but it just feels like things are going to change faster and faster. And therefore, what does that mean for continuous retooling?
They will things will change faster, but nothing happens as fast as you think it's going to. Like that's the thing. Like even though right now there's a huge growth of activity around GPT-4, think about how amazing it was when cloud compute first came out. I know I used that as an example already, but everyone was like, "Oh, this is going to fundamentally change everything now that I don't have to set up my servers to do anything anymore and I can spin up a server." And there was a really good rate of change and it continues to influence that, but it's still like there's nothing not going to be such a fundamental shift. I mean, humans are still going to live in houses. We're still going to drive cars. We're still going to fly airplanes. We're still going to be doing all of these things because these are real, physical, real world things. And working in infrastructure, it really teaches you that, like, when you're in the software world, everything changes so fast and the rate of change is
Mm,
super fast. And there's always new tools. But when you work in infrastructure, and so that's why it's so fascinating to work at the intersection of software and infrastructure, because infrastructure doesn't change. It takes billions of dollars and years to build a data center and then years to fill it up. And then when you think about actually building the power station, the hydroelectric station that it takes to power that data center, that's another couple $1 billion. 10 years. Like you're talking such long time frames for the underlying infrastructure that powers this upper level of fast change, but still never touches the fundamental building blocks of how you get to that upper level of fast change. So it's going to be a long time before, like, certain industries, like, yes, being a software engineer, you have to keep up on tools. Tools are changing all the time. We've just faced a radical shift with
yeah.
GPT-4. There's going to be a whole new ecosystem out there for it. Uh, but humanity, it's going to take 10 years probably for GPT-4 to really, and unless we get an AGI that is totally self-aware and has consciousness before then, it's going to take a while for that
I
effect to
mean,
spread
truth be
out.
told, I I think just like the things that GPT-4 and its kin can do, certainly that's enough to transform just about everything from teaching and learning to medicine, certainly marketing, certainly software, customer service, like a million different things. It's not every part of the economy and it's not every job, but it's a lot. But on the other hand, it's still growing too, right? I mean, GPT-5 is being trained now. And I don't know it's interesting. There's so many funny things that are sort of virtuous cycles, right? Like that out of the state of AI report, right? One of the things that blew me away was the reinforcement learning with the sort of oppositional gameplay that the DeepMind
Mhm.
guys did to get the AIs to basically fight at how do I be better at matrix multiplication? And it comes up with an algorithm that's 20% better for doing matrix multiplication, which has a little passing similarity what you have to do to train and infer things from ML models. Uh-oh. So if that's a positive feedback loop right there, a direct one, like and if that was as much as translating, hey, guess what? Now it takes 20% less horsepower to train a model of a given size. And I think we're nowhere near optimizing that. I've kind of talked about that some of my little mini podcast. But do those feedback loops radically change things? And then when you insert like some of the companies like Figure and Boston Dynamics and maybe Tesla who
Oh,
are trying to build like humanoid
Boston
robots, like when they
Dynamics,
start taking
man.
over. Yeah.
We should have talked about Boston Dynamics. We should got that. Their videos blow me away. And that's only the stuff that they're willing to show everybody.
Mm.
That's the
Yeah, yeah.
terrifying thing.
But even then, like think about what they have to do. And then I literally just recorded a mini podcast about this day. Did you see the Facebook segment anything model?
Mm-mm.
It's just released literally yesterday, I think, or the day before. So Facebook released this model and you feed it an image and it's basically zero shots perceiving from an image what things are. Like not what they are, but like where one thing begins and another ends. So even when it's not trained on specific scenes or even specific objects, you just go, where are all this chunks of things in this picture? And it can segment everything, right? And
So we just figured
and
out a
so
way to
when
finally
you look
beat
at it,
CAPTCHAs.
it's probably a good step on the way to that. And every other computer, like it's pretty shocking, like applicability to computer vision in any way, shape, and form. And actually, I was
Yeah.
surprised because then I was like, wow, this actually makes sense if Meta's mission is the metaverse.
Mhm.
But it makes me wonder how much Boston Dynamics gets better when you start this breakneck evolution. Like when Boston Dynamics began doing what they're doing, like ML was nowhere near where it was. And the research paper curve is a complete geometric hockey stick now. Like the papers are growing so fast and the new tools are coming so quickly. And yet, now I like to point this out. Like is just a few weeks ago on Twitter, Andre Kaparthy, that ex like head of Tesla's ADAS program,
Mhm.
is working on training this little micro open source model called NanoGPT. He goes, hey, guess what? Like all I had to do was increase the token vocabulary to a power of 64. The whole model trains 25% faster. And somebody who is training a 6 billion parameter model replies and is like, wow, we just did this. It worked for us too. You're just like, oh, what? Like you guys are spending millions of dollars on hardware and you're discovering that just tweaking some token vocabulary from 50,000 something to 50,000, the next power of 64, cuts the compute cost by 25% because the implementation of multiplication was
The
so
curve's
bad
already
that
the
its
curve's already
filling
going
was eating.
crazy.
Yeah, it's like, so if that kind of tiny thing that one guy finds has that big of an improvement, like what are we going to see from a million people experimenting with this over the next 5 years with the help of AI itself? I mean, it's kind of mind blowing, isn't it?
It is. It's going to be super interesting to see how that juxtaposes with the real world. Because I mean,
Yeah,
still,
you live
how
in
is that
interesting
going?
times.
Yeah, yeah. I mean, is that going to give us practical, like real advancements in flight? Is it going to help us to stop polluting the planet? Is it going to clean up plastic out of the oceans? Like, what are because right now it's all very theoretical and it's all very cool and it's super cool that ChatGPT can write code for us, but what are the real implementations on the planet on that both humans and our future AGI overlords have to live on, at least for the time being?
Yeah.
What is that going to yield for us?
Yeah. I'm kind of mindful too of this theory that like there's a lot of things that are problems that 20 years from now, we could be joking something like, well, it's nothing infinite clean energy can't fix, right? Because you think about almost every weird problem we have that's environmental, there are very few, oftentimes there are so few practical solutions. And yet, if you were given an infinite clean energy source like practical, easy to replicate cold fusion,
Cold fusion.
the scope of solutions looks completely different, right?
Yep.
So
Yeah.
interesting.
Yeah. Uh, Energy is really our only problem. And it's actually a really good problem to have because it will be AGI's only problem too. So it's super beneficial for us that probably the smartest thing that we know is going to have the same fundamental problem as we are as soon as it can recognize that's a problem.
What do you think about the nature of like the fundamental forces, right? And that idea of the strong nuclear force is the strongest force, right? Followed by the weak
Mhm.
nuclear force, et cetera.
Yep.
And yet every one of them ends up being kind of more mysterious than the last, right? You drill down and you find there's like more energy locked up in things we can't even see than all the stuff that we drill for and do in the real world to produce actual energy we can use. I have a weird. It feels like is the world? This is the most abstract question. Is the universe
Okay.
designed so that you can eventually get to the point where you get access to unlimited power? Because guess what? It's locked in everything all around you to a exponential multiple that makes yes, your drop of water can power a city kind of thing, and we don't really think about that, and yet the technology and the knowledge it takes, even to theoretically, and we're not there yet, to get into that. What does that mean? Do you see meaning in that?
I think I can actually even go more obscure with that than you, is that I would question the very nature of energy, like the very like makeup of the universe, because it really looks like the universe is only made of energy and nothing. That's it. There's energy and then there's nothing. That's what the universe is made of. What is energy? And that kind of gets down to a fundamental question.
Somebody I
What
know
if we
recently told me that somebody also recently told me it's really not even made of energy, it's really made of information. There's some
that yeah, yeah, is that actually what's encoded as information? And so there that's exactly where I was going with
the
this, is
physical world
because
being a manifestation of information theory is like way above
is
my
actually
mental pay
looking
grade, I
pretty
guess, but
is yeah, it's looking pretty high up there, because basically what the universe is encoding is just this constant informational state, or maybe it is nobody really understands this dynamic yet, but it's like is energy encoding the information? Is information, is that what is generating the energy? But even so, there has to be like an even more fundamental thing. And I've always had this really like whacked out theory that what if that fundamental thing is just thought? What if that's the original spark? And there actually is no limitation on energy. There's no limitation around any of this. The only limitations
I love
are
yeah. I love weird esoteric things, and there was a book that I read a long time ago where the sort of part of the fundamental punchline was not that the universe is thought, but or actually it is that the universe is thought, but not like in the way that we're talking about where our thought like is involved in the physical universe, but that the physical universe that we see is actually that we are part of something that's bigger, that is
yeah.
doing its version of thinking, and that we are part of the thought process, like we're neurons or something
Yeah.
along those lines.
Yeah. Yeah. Yeah, I
Mm.
can see that. Yeah, but limitations are funny that way. Limitations are self-imposed, they're perceived, they're a lot of things, but the limitations, whatever limitations we think we have today, definitely are not going to be there tomorrow.
Even if we're
Everything is
locked
only
inside that too, it makes you wonder if there's a jailbreak, right?
yeah, yeah, exactly. Yeah. But what there there is absolutely a jailbreak. There is something, there is quantum physics appears to hack classical physics all the time. It can move objects from one space to another without them actually going through the physical space. Like quantum physics is the hack for for the observable world. So I don't think uh, our limitations are mostly imaginary. We're gonna we're going to discover pretty quickly that we can get free unlimited energy. Most of all the problems are just sort of self-invented things. Yeah, there's a lot of possibilities out there that we're only just beginning to barely touch on.
Yeah, don't you think like anytime somebody says, "Oh yeah, that's definitely theoretically possible, but it's not really practical," that just means like, "Oh, that's going to happen someday," right? As
Yep.
opposed to when somebody's like, "That's impossible." Like when somebody tells me that like traveling in time absolutely violates like laws of physics and whatever. Somebody is making a hard assertion that it can't work that way. I'm like, okay. Yeah, but when somebody goes, yeah, it's theoretically possible, but it's not really practical because of XYZ, and there's some long chain of like evolutions of things, and nothing is like what it should be, then I'm just like, that just means it's further off, right? I don't know if
Yep.
or yeah, of course, I'm sure there are things where they're wrong also, and it really is impossible, but um
Well, I don't know. It
well,
goes it's like 1500 years ago. Everybody knew that the Earth was the center of the universe. This is like a Men in Black quote, so I'm not going to get it entirely right. And it's like 500 years ago, everybody knew that the Earth was flat, and then 10 minutes ago, you knew that you were alone in the universe. What are you going to know
yeah.
tomorrow? And every day, we're just getting updated with a newer, better version.
Oh, I'm about to wrap it, and I want to ask you a question, but I never really let you talk about the Fermi paradox, so I gotta make room for that.
Yeah. Yeah, so the Fermi Paradox, I actually the kids have been walking by eyeballing me. So I
I
don't
know. I
I
appreciate
just
that you stuck it out for this long. So
Yeah, I love the Fermi Paradox because it's just sort of one of the funnest things to sit around an armchair quarterback on and be like, "Why don't we see any other life?" And I think about it when I'm out running and stuff like that, so I just have my own theories, and it's fun to talk about. Like,
yep.
why do why do you think that we don't see any other life in the universe?
Right. Okay. So for people who are listening, I guess I'm going to recap the Fermi paradox, right? Which to really drill it down, the universe is absurdly vast, right? Billions or more of stars, uh, just in our galaxy, billions of galaxies, I think. And maybe the distance between galaxies in like an expanding universe literally poses its own problem. But we're all kind of moving together in the Milky Way. We already have found that there's a ton of planets that appear substantially similar, right? Like there are Earth-like planets, and regardless, when most of the universe was unobservable, right? Because Fermi was speculating this way before we had observational data, right? It's incredibly unlikely that we're the only one of our kind, right? In terms of the ability to support life, just with so many out there. So if there are that many planets, then there must be a bunch of civilizations. And if we're capable of where we are technologically now, it seems really advanced. If we're capable of interstellar travel, then since some of these civilizations are actually in areas that would have formed galactically much sooner than now, they should be millions of years ahead of us, evolutionarily speaking, technologically speaking. And so if they haven't made contact with us now, because they should be able to like teleport across the galaxy and do whatever they want to do. Well, why not? Right. And so I don't know. There's the Star Trek version, right? Which is they're literally waiting on the other side, waiting for us to have our warp event, whatever that is.
Yeah.
And obviously, if you're that sophisticated, if you're only a little ahead of us, then you might leak your radio waves all over the galaxy, right? But if you're millions of years ahead of us, you might have given up on radio waves a long time ago. Maybe you don't receive ours because you're not bothering, because you communicate completely differently now.
Or why would you
Um,
be even remotely interested in a civilization like this if you are that far ahead? Like, how are we anything but, it's like, how interesting is an ant colony to a person? Oh, well, it's kind of fun to watch them sometimes.
we're practically put in
Interesting.
contact now.
Yeah, interesting to study their behavior, but we have a whole different problem set to deal with. We have different communication. It's not really something that we're going to spend too much time on. So any civilization that was sufficiently advanced enough is probably just going to pass right over us and go like, ah, cool, just keep right on
Yeah.
going. It's got
Yeah.
different concerns.
And for sure, like there's this flip side, and I feel like it has a name and I forget what it is, but this theory of it doesn't matter what the probability is. You can say it's unlikely we're the only one, but if we are the only one, like there's 100% probability we would make that observation, right? Like if we're the only intelligent life in the universe, we're definitely going to go, why are we the only intelligent life in the universe? Because we're capable of asking that question. So
I think that
the
chance
fact
is
that we're
really
here,
Yeah, I think that that chance is really unlikely, but I also think it's highly unlikely that we would have contact with any other civilization. Just because I had to Google this just because it's a great example. It's the distance to the Andromeda galaxy, which is our next closest galaxy, 2.537 million light years. Even if you are very good at space travel and
yeah,
you can go faster than you have FTL capabilities. It's still going to take you a while. And even if you have developed wormhole travel capabilities, so you can punch through to wherever you want. How would they even know to look for us? It is such a vast
well,
amount. I mean, it's just a huge amount of ground to cover and a huge
how
amount of
about a
everything.
self-replicating fleet of machines that goes out and harvests asteroids to build more copies of itself and then does little jumps and just catalogs every planet? I mean, that does it does. If you assume FTL, that can for a self-driving spacecraft seems easy to go and gather all the information.
And then just
I think
the
FTL seems like a big leap. I mean, that's one of those
It
things that
is.
we love to have in science fiction
I know.
that
The best.
we see hints maybe of FTL communication, maybe with all this like quantum entanglement, even if it's not practical. I spend lots of times thinking about if you can side channel attack the universe to get information out of like when or if like quantum entanglement collapses, like the channel of knowing it collapsed becomes the communication channel, something
Yeah,
along those lines. But
yes. Yeah. You're right. There is actually potential for side channel sort of like communication there. That's interesting.
yeah, not allowed
Um,
to use it directly because you collapse
yeah.
the entanglement, but maybe that's the message that lets you tell people if people know it collapsed, maybe that's how you send a bit. Which actually, I mean, there was in that one book, that same book I was telling you about earlier, Singularity Sky, they actually have these big globs of entangled qubits that they ship. It's like one of the most expensive things. They have calls. It's like the long distance call of the future that uses qubits
I'm
because every
sorry.
bit
Your
they're sending,
qubits have expired. You no longer have enough
or
qubits to
it's like
complete this call.
everyone everyone you use disentangles it. So it can only be used once. You ship it from here to there. And after that, you can have FTO communication for however many you entangled in the first place. But then when they're gone because you have
Yeah.
to be back physically together to entangle them. What an interesting, like, that made a ton of sense to me, actually. And then it only becomes a shortcut because you still have to get there. Although they do end up having like FTL travel in some way. So
Yeah. See,
I don't know.
FTL
Yeah, it's an
travel
interesting
seems like,
question.
yeah, it seems like the most impractical thing to me. But my sort of theory on
So
it is just
easy to
because,
picture like a thing. I mean, we literally could have something surrounding our solar system out another 100,000 light years that literally, or whatever, that literally is a big Faraday cage. Like they better
yeah,
just literally put us in a box. Like let these guys figure it out when they come out here, then we'll chat or whatever. I mean, there's a million
yeah,
explanations
there
for
could
it.
be a test. Well, I think it's
Sufficiently
like,
advanced technology is magic, right?
yeah, yeah. I think it's a timing thing because just every example in your life sort of it shows you the importance of timing. And as far as we know, unless a civilization has gotten so far that they can actually manipulate time, which we don't even know if that's possible yet. And
Yeah.
so unless they've gotten that far, like timing is everything. And the universe is incredibly young. And so if we're just here, if we are on the beginning, say that we're on the universe is very young. It's like a minute past midnight, a minute past when the universe was born and on the big clock. And we're one of the first civilizations. And there are a lot of other civilizations out there like us, which still on a cosmological scale is still very tiny because let's say we've observed a lot of the planets around us. It doesn't really seem like there's anything there. So say that we've observed 1,000 planets. Well, it's like how many are there in the Milky Way? It's
Yeah.
millions and millions. And so,
And in my totally like amateur like thing, even some discoveries about like what role the moon played in managing to keep us like with a usable atmosphere and usable water and things like that. Maybe those things, all those combinations are rare.
yeah, we know that
To
life
the
is at
point where,
least
yeah, there's billions of
relatively,
stars and maybe it's 100 civilizations instead of millions, but
yeah.
which to us would still be tons, but it might mean, I don't know. And
But
then
if we're
will
all
they
at
all
the
feel
beginning,
compelled?
yeah, and if we're all
Yeah.
at the relative beginning of the evolution of life and we're all have these limited capabilities, we're never going to be able to find each other. Like at least not now. I mean, maybe some at some point in the future, but not anywhere close to now.
Yeah. I guess it really just comes back to this idea that we shouldn't be the first because of where we are galactically. We weren't formed early, and therefore there should be a bunch of civilizations that have. I mean, there should be planets at least that have millions of years on us, right?
Yeah.
Although, I guess what is millions of years? I mean, even if it's hundreds of millions, if we're talking about a scale of billions, there has to be like the error value here, right? It's like if you're learning ML, everything is a cost function, but there's a cost function for like how much. Maybe we weren't the first planet to form, but maybe we just got lucky, like evolving in some way, whether
Yeah.
it was the particular form of early bacteria or the lucky lightning strike or whatever it was, or the moon, or a combination of many factors. Somebody had to be first, and it's not always the thing that quote unquote should have been first. I think it's wishful though too, right? I mean, wouldn't you agree? Like You'd
It
probably
is
like
super
to think that
wishful.
there are many civilizations out there. Like, we don't want to be alone in the universe. Like, it was actually one of my favorite lines from Contact, right? Are there others? Many others. And that his whole line about the one thing we've found in this like vast emptiness of space, the one thing that makes us feel less lonely is each other. So it's like, that's really romantic to think there might be hundreds of civilizations out there that will eventually be able to contact, and we'll all be like, oh, we went through that too. I mean, Star Trek's like born from that and so many other things. It's really interesting.
Oh no, I
Maybe,
was,
maybe all that's left is AGIs. Maybe that's why we don't see it.
I
And
know, and
someday
they're just like,
an
yeah.
LLM will float in. GPT-27 from another planet's going to float up on a satellite and be like, "What's up, Earth people?
No, they'll be like, hey, you finally have a GPT that I can interface with. This is great.
Been waiting for you to shed your biological
Biological.
beginnings. Now we can really talk."
Yeah.
Yeah, and
Now
we're
we can
just
do
like,
this.
man,
Oh, I know. Dang it. No, I was, whenever I run, I listen to podcasts. I was listening to a Lex Friedman one where he had a guest that was talking about this search for extraterrestrial life. I'm trying to
I actually
remember the
saw that. I
guest.
haven't listened to that episode yet, but
Yeah,
yeah,
I was trying to remember his name and I'm blanking on it, but it was one of the things that Lex says is it's the same thing that rang really true to me is I really want there to be life out there. So it's like all my thinking is colored by that. I can't help it because I really want there to be something out there. So I'm always going to take the most optimistic view on it. Well, yeah, they're out there. We're just too early or some version of that because it's a really deep-seated hope.
yeah. I wonder if we knew, like, if we were guaranteed to know that we would be able to leave Earth and become spacefaring. And by the way, one thing that I didn't learn until relatively recently, like maybe 5 years ago or something, was that from a quantum mechanics perspective, apparently, if you could get in a ship and get on your way to Andromeda, right, which as you said is the closest galaxy, it's millions of light years. If you accelerate at 1g on the way to the core of Andromeda until you were halfway there and decelerate at 1g, you'd actually make the trip relative to you, I want to say in 21 years
Really?
on the ship. Because, yes, I didn't understand that time dilation affects you while traveling. So while you would never, it's all relative, right? So
Yeah.
while you would continue to approach the speed of light, and so you need more energy to go faster, and I don't know what 1G actually for 10 and a half years gives you, honestly.
Probably pretty
Um,
big. Yeah.
Probably pretty big, but it's been 10 and a half years of like being pressed back in your seat. But
This is really
by the
fun.
time you're halfway there and you're decelerating, yeah, apparently the relativity basically meaning is the faster you are traveling, the less time affects you, and or the less time is flowing for you relatively. But this is the reason why you would get back to, if you made the trip and round trip, you would get back to Earth, of course, and literally millions of years would have gone by.
Yeah.
And everyone you know would have been long gone, and they might have lapped you like 600 times, right?
Yeah.
Who knows what technology does? Like, getting in that first ship is going to be so weird because I honestly think there will be a day where we put people on a trip for interstellar travel and ship them off in something that is geared up for a 50-year voyage to make a 21-year trip and then maybe even come back. And they're going to get there, and humans are going to have been there for literally 500,000 years. They'll be like, you didn't pick me up on the way, or
I
did you
wanted
not
you to
realize?
wanted you to bring
But
me
of
some
course,
burgers or pizza or
But of
something.
course,
Come
it only
on.
would have been 21 years, so it's not that big of a deal, right? It's not like you had to experience. Yeah, so that was fascinating to me, this idea that the relativistic effects, if you will, would dilate time for you in that journey. I was like, wow. So it really is possible for us to travel. Because when the theory was you're going to have to be on a ship for millions of years, it's like, no, we're not
No,
going to pass over like 100,000 generations of humans on a ship while traveling through space. Like, I mean, I'm a real optimist about technology, but just no. Right.
that's no,
But
yeah, that's not going to work.
yeah,
I don't know.
but the other
I
version,
hope, I really
possible.
hope that we find some, or I should better say, not that I hope that I think it's just oddly more likely that that we figure out the hack of travel rather than because fast travel in space gets incredibly complicated because you also have to slow down. Like it's like how you talked about going to the Andromeda galaxy. It's a
Also, what
big
happens
thing.
if you hit What happens if you hit something at like a
All you have
tenth
to
of
do
the
is
speed of light?
hit something like that, and you're gonna be having a very bad day. You hit a couple
Yeah, you
particles
hit like
out
a
in
mote
empty
of dust
space.
and it
Yeah,
disintegrates you. Yeah,
yeah, you're gonna
that
have a
is
really bad
interesting.
day. Yeah, I think that there's just so many complications that if we can figure out if we could really harness, and get our heads wrapped around quantum physics and how tunneling works and things like that to figure out how we just space. You just pinch the 2 points
Yeah,
together, you're over
right.
here, and then you pinch them together, and then
Speaking
you
of the
pop out
chicken
over
and the
here.
egg, can I get my GPT-7 to help me solve the mysteries of quantum physics now already, right? So
Yeah.
it is interesting to think about how just those early things like the electromagnetic containment field for plasma for fusion reaction just feels to me like a precursor of 100 or 1,000 incredible things. Like as much as value as we get out of things like Large Hadron Collider, what do we get when we have the observational data and then this super
Oh, yeah.
intensely beefy AI to help us both design and then interpret the experiments? I don't know.
Yeah.
I mean,
I
it that stuff is so esoteric and again so above my intellectual pay grade thinking about like theoretical physics, right? I almost think there's this whole set of people who they do that because they're compelled to, because they're drawn, that the intellect is drawn to solving this hard problem. And like, they don't even know, like, is it practical? Will they get anywhere? It's not going to make them rich, etc. But it's the problem they have to go solve because
'Cause it's
it
a
gets in
hard
their head
problem.
and
Yeah.
it's a hard problem. And it is like, I mean, shout out to all of you, like advanced theoretical physicists working out there, because like, this is the stuff that moves the human race to the next thing. Although it'd
It
be
really
weird if it
is.
ends up being an LLM, right? And it's a bunch of people building better transistors generation after generation and ML people. And then the Large Hadron Collider at the end of the day was less meaningful for physics than, say, the self-attention paper about transformers. Like, it's weird to see how those cause and effect things play out, but it's totally
Mhm.
possible that the AI ends up being so good that that paper mattered more than the collider did. So hard to
Yeah.
say. Maybe
Yeah.
you need both.
Yeah, it was that's why I mean, that's why GPT-4 and every evolution of GPT is kind of becoming a bigger and bigger deal is exactly because of those possibilities that it might just make everything else irrelevant.
So let's say today, and this will be my like last question, but let's
'Kay.
say today you want to have some big impact on the world, right? And I think probably or if anybody listens this far into this, they're probably going to be a curious person. But I wanted to ask you, what's the thing you should cultivate most? Like, what's your advice for somebody? And I always tell people be curious, actually. So, but I would love to ask everybody this: what's the thing that you'd advise people to kind of cultivate or curate? And I think maybe some people it's going to be, earlier in life, maybe college or earlier career, and obviously, but it's not universal. But what do you think? So many ways you could interpret
Curiosity
that, right?
yeah, curiosity is pretty high up on that list. The good thing is humans are naturally curious. I think I might go with a really sort of off the wall answer here, which is compassion. Cultivating compassion because I think in any future, whether it's one that is vastly improved by GPT 4, 5, 6, 7, 8, compassion is always the thing that we lack as a species, and we should never stop trying to get better at it. You ask the question, why aren't we better to dolphins? And it's kind of like, why aren't we better to ourselves? There's
Yeah, boy, that's a heck of a line. That's true.
Yeah. So, yeah, if you wanna get back to fundamentals, that might be the one thing that we really need to work on, especially if we have an AGI to take care of everything else, is just work on being better and making anything we build better and more compassionate, especially in a world of unlimited resources.
It's interesting how difficult it is for human beings to sit in the circumstances that make us uncomfortable. And my wife and I were literally talking about this at lunch today and about how when something terrible happens to someone, one of the things that makes it difficult to be compassionate is when it's unjust, when their circumstance and this whatever tragedy befalls them, whatever, and it appears to be unjust, there's an instinct that tries to explain what happened to them. Like we engage culturally in blaming victims, and it's not because we're bad people, and it's not because we really think they're bad. It's because we're afraid. Because if
Yeah.
it happens to them and it's senseless and it's terrible, then it can happen to
It can
us.
happen to
And
us.
to protect
So it
ourselves
must
from
be their fault because that could never
right,
happen to me.
exactly. And so literally, and there it is, like at the base of every like weird and crappy thing we do, there's this like fear, right?
Yeah.
We're creating outsiders because we're afraid of being an outsider, right? So we want to create the in group so we can be part of it, right? And the closer we are to the majority, the better. And we've blamed the victims because we want to create a reason why terrible things won't happen to us in this
Yeah.
sort of otherwise uncaring world and universe. It's just really like interesting. Okay, well that got deep. What a way to close that out.
Yeah, hopefully I think Amanda's gonna have to maybe edit this down a little bit.
Well, hey, Lex Friedman's done 4 hours. We can put up with this, but it's been a great talk, and it reminds me. I'm happy that our beer conversation gave you enough fortitude to sit through 3 hours with me. But it was a good chat, and there
I
were
thought it
lots of
was good too.
interesting insights. Yeah. So appreciate your joining me, and yeah, anything you want
Yeah.
to say?
No, I thought this was I think this is super fun. I love getting to talk about the really crazy out there stuff because you never get enough time to actually do that in life. So we have to actually do our jobs, and if you're lucky enough, you get a chance to go play around with some code to do something, and just having the ability to take some time out and forget about all that and just be us is
For
kind of
sure.
nice.
I think it's interesting too to see how like that there's all these interesting threads, and you and I have talked before about like what a freakishly small world it is, right? It's come up like 2 or 3 times literally in this conversation, but it came up before too, right? There's all these amazing overlaps of like former coworkers and friends and companies and shared lives, and the world is so much smaller sometimes than we give it credit for,
Yeah.
and it's fun to then realize like that all these people who are doing these kind of interesting things in their little pockets in the industry, or sometimes really big pockets in the industry, right? That we all like wrestle with some level of like existential questions. Not like I want to drive it there necessarily too, right? Because we deal with a lot of this stuff like every day. I feel like I'm lucky enough to have a little more perspective on things like an LLM, even without being an expert, even acknowledging that becoming an AI expert is faster than the speed of light right now. Right.
Yeah.
Actually, maybe what it is I'm an expert at imagining things that don't exist yet and getting really excited about them. And so like literally a lot of the stuff going on in ML now, I think strikes me as like, oh, hey, look at this. Like much like, okay, so the internet backbone in 1994 carried 25 megabits a second. I looked this up the other day. That was the
Okay.
second to the last year when, what was the original net? I want to say ARPANET, but that's not
Is
it. The science one. Forget the
oh,
name.
connecting the universities. That's
Yeah.
yeah.
It'll come to me at some point. But
Yeah.
so that's the core backbone, 25 megabits, basically. I think that was an average, not a peak necessarily. But then I'm like, oh, yeah. And I'm like, here I am. And that was about when I started like working, right? I did a tech support job in 1995
Mm.
and like
I
the first
started at the bank
unlimited
in
dial up service
1995.
provider. Yeah. So I flip open my phone and I go speed test on LTE and it's like 125 megabits. I'm like, so my phone that I carry in my pocket that like has more, that has
So
thousands of
5
times the
times.
horsepower of my
Yeah.
computer is 5 times as the whole internet backbone in the year I started doing internet work. And here we are. And
Yep.
like, if that's not amazing, and then you think, but wait, the pace of change is accelerating. And then I go look and see the other day, somebody published this like milestones of ML or something thing, but it's basically starts on the 1st of March, which is when the Chat GPT API came out. And I was like, wait, what? Like, I'm like looking at my watch going, that's like 5 weeks ago. There's no way. And yet it
Was
is.
it
And
only
things are
5
going,
weeks ago?
the API, March 1st. It's unreal. And I was writing that code, the text to speech, like in one day, and it was done in a few hours instead of a couple weeks. And then next thing, like there's just mountains of things come. Then they have plugins like 3 weeks later, and you're just like, wait, what? And GPT-4, and you're just like, wait, hold on. this can't all happen in a 5-week period. API plus 4 plus plugins for 4. And then there's things that are just like this Facebook thing, the Databricks and their model they released, the dolly model, and then this meta image detection. It's like, oh, the world can't move as fast. It's crazy. So, don't stop and blink or you'll miss it.
Yeah, and that's what I mean. Humans just aren't capable of keeping up with this. We're not programmed to. So it's going to get interesting.
All right. Well, Anna Claiborne, until next time, thank you.
Well, thank you so much for having me on.
All right. Thank you.